Cool. Hello, everyone, and welcome to the second workshop powered by Kubesimplify. And this workshop is Kubernetes 101. My name is Saiyam Pathak, and I am a CNCF ambassador working as Director of Technical Evangelism at Civo, building the next gen cloud platform. So, Civo is a cloud hosting company that has its own managed Kubernetes offering based on K3s. And yeah, I'm very excited for this particular workshop. I'm going to deliver it. So this will be interesting. And I love the enthusiasm going on in the chat. So hello to all the people who are in the chat. Thank you so much for joining in, and make sure to share the stream now. So you can copy the link and share it all across your social media so that maximum people can take the benefit. Now, since you have joined, just be there for the next few hours. And whether you are new to Kubernetes, whether you are revising Kubernetes, just stay there. Just hold on for a few hours. And I promise you that you learn something today. And it'll be fun, exciting, hands-on, a lot of Q&A, everything, lots of stuff will be there. Just hang in there till the end and enjoy the workshop. Few things first. Make sure to be respectful to each other in the chat. We are all here to learn and not to comment or do any stuff. So this chat is moderated by Kubesimplify ambassadors, and they will be moderating the complete chat. They'll also be available for the Q&A, and will try to help and keep you all going. Make sure to join the Discord. Let me just add the Discord link. So make sure to join the kubesimplify.com/discord, because there you have a workshops channel. And in that, so basically in YouTube chat, you won't be able to post screenshots, links, all that stuff. But in Kubesimplify Discord, you can post your queries, your concerns, what is working, what is not working, and our ambassadors will make sure that your query is getting answered. So I think that's a very good way. I think last workshop it worked really well. This workshop also it should work really well. So kubesimplify.com/discord. Make sure to join the workshops channel, and anything that is not working your site, it'll be managed by the ambassadors. So now let's kickstart our Kubernetes 101 workshop. Yeah, one last thing. Promise, one last thing. So before, many people were asking, what are the prerequisites and all that stuff. So prerequisites are actually the workshop one. So workshop one was taken by Chad. It was Docker and Linux fundamentals. So if you have not watched, then possibly you should have watched that, because that's workshop one. Because I'll not cover the basics of containers and all that stuff. This will be core Kubernetes hands-on from scratch. And let the fun begins. Let me remove the banner first. Okay, let me share the screen. I hope you're able to see the screen, and I'll take out my magic pencil and we will kick off. So today's session is all about Kubernetes. And there are a lot of things that I want to cover. A lot of things that I have left, because this is Kubernetes 101 workshop, and this is not complete end-to-end Kubernetes, and it cannot be. We cannot cover that in a single kind of workshop, because there are a lot of contents, a lot of topics, but I'll give you all the pointers in the end where you can go to learn further. Obviously my channel, but I'll tell you that. So in this workshop, what we will cover is introduction to Kubernetes. That is very, very important to set the stage right. Then the basic components like pods, deployments, stateful set, networking and services, some level of the authentication, authorization, and admission, then the Configmaps secrets, and if time permits, then probably a local and a kubeadm setup. I think I'll do this one. I'm planning to do this one, but this one, if the time permits, I'll show you what it can be there. So a lot of things to cover. Hang in there. Get set, go. So introduction to K8s. So first is the first kind of section that I want to cover, introduction to K8s. also covers a lot more. What is Kubernetes, why Kubernetes architecture, YAML file, what is it, Kubernetes components, imperative, declarative, namespace, label selectors. So this is actually before going into any of the real hands-on stuff, because you need to know some theory. That is true. That is true for anything. Like you need to know some basics, some theory, and after that you can, kind of go do the hands-on. And don't worry, I'll tell you where to do the hands-on. You can easily easily join and perform the tasks within your browser. So there's no worry, whatever laptop you have, you should be able to join. So what is Kubernetes? As per the like talks or wherever you have read the definitions, Kubernetes, also known as K8s. K8s is, why do we say K8s? Because there are 8 alphabets between K and S. So it's an open source orchestration system for automating deployment, scaling, and management of containerized applications. It is a CNCF graduated project. So this project is hosted under the umbrella of CNCF, and it is a graduated project over there. Now, what happened was, in back in the days, you all know, like Google. So Google has massive scale at which they run the kind of infrastructure services and all that stuff. So internally, they already were running a few systems. They already had developed those distributed systems called Borg and Omega. So those were the closed source system, and which were solving a large scale type of problem. I think they still might be there because they are handling stuff at massive scales. Now Kubernetes was born with the best practices, with the learnings, with the same DNA, sharing the same DNA of Borg and Omega. So that's how like Kubernetes came into picture. It was first launched in 2014. I would not say it's fairly new, but I would also not say it's fairly old, like the programming languages Java, and also it's still fairly new and people want to learn. People are learning in today's era, especially where the containerized application is everything. You need to know. So, like Kubernetes is need of the hour. Even if you're a software developer, if you're a DevOps engineer, SRE, developer advocate, support engineer, any of the any of the workings that you are doing at a particular organization, you definitely need to know containerization in Kubernetes, because it is the need of the hour. To be very honest, I won't say like, if you're doing this, don't do it. And also it adds a lot of plus, a plus skills to your whatever you call resume or profile or skills knowledge. It is very good to have Kubernetes knowledge. Designed for scale. So Kubernetes is actually designed for massive scale, like 100,000 containers, 100,000 pods, and it can run anywhere, like on your Raspberry Pis, on your bare metal systems, virtual machine, clouds. So it can run anywhere. So that's Kubernetes. Like you have learned from the previous session, like containers, right? So you have containers. So who is orchestrating them? It's K8s. So that's the fundamental. Like although K8s is doing much more than just orchestrating, because it is doing the scaling, it is doing a lot of things which we are covering just below this. So why Kubernetes? So that's a very critical question. Why actually we need Kubernetes when we have containers? Okay, we have learned Docker, we have our file in Python or Node, and we have containerized it using written Docker file for it. We did Docker build, and we created an image, and then we did Docker run. So it's running fine. What's the problem? Like I'm running it, right? So my Docker container is running. I'm able to serve the traffic to my application, do the port forward and everything stuff. Then why do I need Kubernetes? Such a complex ecosystem where you need such a huge learning curve and all that stuff is there. Why do I actually need to learn Kubernetes? Now the thing is, this is fine. You are running a container. Few containers are fine, but what about scale? I'm not talking about 2, 3, 4. When a monolithic apps, when a monolithic application, so this is a monolithic app, when this gets divided into microservices. So there are different APIs. Take any example, like any ticketing system, booking, or air flight booking. So they have a lot of pages. They have vacation page, they have hotels page, they have bookings page. You go to each pages where you have the payment gateway page, where you have the flight search page, flight booking page. So you can see so many microservices are there within a single application. And so this is the first set. So this is the first set. Now you need to run, in order to maintain the availability of the application, that something doesn't go wrong over a Black Friday sale or whatever sale is there. Then you scale it. You have another set of these same microservices. What about the development and staging environment then? Okay, let me scale it more. So this was for prod environment. Let me create dev environment. Let me create stage environment. Let me create the pre-prod environment, and let me just do all again with same number of replicas. You can see the overhead. So now you are managing like thousands of containers. Now tell me, if what happens when this goes down? You manually need to fix it. What happens if this goes down? You manually need to fix it. How do you monitor each of them? Custom scripts. How many custom scripts you will write? So you have to write so much custom scripts to monitor one environment, second environment, get the metrics, trace the metrics, then build another system for that. What about the flexibility? What about you want to add, you want to extend this, or you want to run it the same thing? You want to create a disaster recovery setup. How would you do that? You have to do the same huge process once again. I mean, that's a tedious job. So we cannot monitor like this. We cannot run containers at scale like this. We cannot monitor them. We cannot run multiple pods in multiple nodes. I need to manually have some logic that, I want this pod here, replica of this pod, another container not here. So many things are there. Then I need to, what about flexibility? Flexibility is not there. Auto scaling, no auto scaling is there. Scheduling, how do they schedule? I have to manually write the scripts and schedule that. What about the self-healing capabilities? Like if something goes down, then automatically can I say, like, I just need 20 copies of my application running, and there should be some person or someone from the application, they are that softwares, a piece of software that is automatically creating those replicas, and I don't have to do it manually. So all these things is done by Kubernetes, and all this overhead that you have to do, you don't have to do. So there is a learning curve for Kubernetes. There are things you need to know about Kubernetes. There is some terminologies you need to know about Kubernetes, but you can see the benefit, right? You can see like the flexibility, the auto scaling, the scheduling, the monitoring out of the box. So many things you are getting when you're running it at scale, and it's built for production. Like you can you can expand from small scale to large scale very easily, because you never know what startup idea you might think right now. People who are in chat, you might be the future CEOs of some company. So you might be starting a small organization with some small traffic, but suddenly you create a killer product, and the traffic goes like spikes. What will you do? You can do the auto scaling, you can handle all the things with Kubernetes, but when you are doing on your own, you can't do that. So that's where Kubernetes comes in. So Kubernetes is an orchestration system. So what is Kubernetes? Kubernetes is an orchestration system. It is used to manage all the containers at scale. So it manages their scheduling, it manages how they run, where they run, it manages their auto healing. Like if you say I need 3 copies of my replica, then 3 copies of your replica will be there. 3 copy replica in the sense the same copies, like a photostat. So that will be there. So that's what Kubernetes is. Now the first hurdle of this particular workshop is complete. Like what Kubernetes is, why we are here. So we are here to learn Kubernetes. Kubernetes is an orchestration system. Orchestration is just running, managing, scaling, monitoring all the containers which are there, and it is a massive piece. Kubernetes is not small. It's a massive piece of software which helps you achieve all these things. Now let's come to the architecture, like how things work in Kubernetes. What actually is there when you say Kubernetes? Okay, so this is architecture. Let me zoom in this area. Cool. So what we'll do is, this is me. This is my Twitter image. I am trying to run a pod. So kubectl. So if, for the first timers, kubectl is a tool, is a command line tool that you use to interact with the cluster. So you need a way to interact with the cluster. You will be using kubectl, kubectl, whatever you want to call it. But I call it kubectl. So this is the tool that you will be using to interact with the cluster. Any sort of operations that you are doing, you will be using kubectl. So kubectl run nginx image nginx. If you're not understanding any of this thing, it's completely fine. I'm just trying to make you understand Kubernetes components. So Saiyam has given a command and wants a pod to run, basically wants a container. Let's come to the pod terminology later on. So I just want my nginx container to run. I can just do, right, docker run -it and give the image nginx, right? So I want to run in Kubernetes. In Kubernetes, how do I run it? I do it kubectl run nginx and give the image -image nginx. Nginx is a web server. So I do that. What happens? This request goes to the API server. Now, what is API server? Now, what happens is, whenever you are talking about Kubernetes, what you will be doing is you will take a few machines in the sense bare metal machines, Raspberry Pis, or virtual machines on cloud. So in cloud, you can create virtual machines. On your laptop, you can create virtual machines. So just say you have created 2 virtual machines. At one virtual machine, you have a thing called control plane, and another virtual machine is called worker. So your this particular pod which is there, this particular container that I want to run, this will run on your worker node. So your worker node or this machine will be actually running your container, and you'll be able to see welcome to the nginx page. Your traffic will be served from this particular machine, which is over here. And then the control plane node is managing everything. Now we are seeing how it is getting managed. So there are different components. So there are different components. So there are different components, and first we are talking about the control plane mode. So control plane is basically, we call it control plane node, and it has the control plane components because it is controlling your complete cluster. That is the whole terminology. But what are the components that we'll be installing that are there? So API server, scheduler, controller manager, etcd, and ccm. Now what is API server? API server is the main brain. So API server is the main brain of Kubernetes. So whenever anything that you are doing with Kubernetes goes to API server, all the calls goes to API server. You can provide a YAML file, you can provide a JSON file, you can use the imperative way of doing the kubectl run, and every command will go to API server. Now, this kubectl run command will go to API server. Now, API server will do 3 things. API server will do 3 things: authentication, authorization, and admission. So user first, whenever a request comes, I need to know, right, if anybody is entering my house, whether that person is genuine or not, whether they have the key or not. So or whenever you enter your offices, you have the ID, right? That's the authentication that you are doing. So that's what it does. A user So a user is authenticated with the headers passed. So whatever is getting passed, so user is getting authenticated. Then it is authorized, like whether a person who has entered is authorized to do a particular task. Like if someone comes to your home to let's say fix a light bulb, whether he actually knows, how would you know whether that person is actually the right person to do that particular job, or whether we need to validate that whether he's authorized to perform this particular action. So that's the authorization. And then you have some sort of policies, like when it is admitted, there are certain policies that it needs to check. For example, very simple example, like when you are running this nginx image, I just need to check that this nginx image is coming only from Docker Hub and not anywhere else. So that I'll be having a image policy webhook. So I'll be checking against that webhook. validate it. I can also mutate. So we are not going to do the details of the webhook validation and mutation, but it is also a big concept like webhook validation and mutation. And then it saves to etcd. Now what is etcd? Etcd is actually the key value database for your Kubernetes cluster. So all the cluster states, like you have your application running in Kubernetes, so your Kubernetes need to know, right, that it is running this application. It will store its information. At least it will store its cluster information somewhere. So it is storing its cluster information. So it is a key value. It is a key value store for distributed system. API server writes to it. And whenever you talk about the HA mode, you will be having three. You will be having three nodes. Like you need to have three. You need to maintain the consensus. I can briefly touch on that. So you need to have three etcd nodes for HA, so that you can and I think 2n minus 1 is the tendency, or whatever is the number. So if three are there, then you can tolerate the failure of one that is there. So you have so this is the for the HA one, but that's actually out of scope of this workshop. But there is, like, for HA you need three, and it uses the raft algorithm. So there will be a leader election, consensus will be there, and the leader will be elected, and then that will be serving as the key etcd where your data, where API server will write. Okay, so where we are with respect to the request. So now we have told API server, I want to run Nginx pod. Now what you are doing. So API server says, okay, I have the request. I have authenticated, authorized, and validated. It looks perfect. Now let's move on to the next stage. From my side, it's okay. The second component that comes into play is called the scheduler. So scheduler is very intelligent component in Kubernetes. Scheduler will find the best fit node to run your pod. It will take the resource and request. So there is something called resource, request, and limit, where you can define how much CPU memory this particular pod needs and what is the upper limit. So you can define all those. So scheduler can read that. Scheduler can take that information. Scheduler also knows the capacity of the nodes. So it has the node information. Like there are three nodes. Like there are two nodes over here. So if it does it have the capacity? Does it have the capacity? Which has the capacity that can actually fit this particular node? So it will intelligently find it and then update the label inside the pod that it has to run on this. So it tries to find the best node based on taints, toleration, affinity, node selector, and updates the pod spec section with the node. So there are taints, toleration that you already define and all that stuff. Then you will be, it will get the best fit node. Now where we are with respect to our request. So we have kubectl run nginx -image nginx. We still want to run the pod. It is not running. What is happening? Where's the request now? So it went to API server, it went to scheduler. Now at least we know that it will run on node A, because a scheduler has said that this particular pod has to run on node A. Okay. Then that piece of information is also stored in etcd. It's updated. API server only talks to etc, no other components. Rest all other components talk to API server, like all our body pods talk to our brain. So we have a central control system. So that's why API server is also there. Now next component, let's move to a separately different dimension, which is the kubelet. We'll come to rest of the components of the control plane later on, but let's move to kubelet. So this is the worker node. On worker node, we'll be having few components which are constant across any number of worker nodes that you add. So one will be the container runtime. You can have Docker, but from 1.24, you can have, but that Docker shim is maintained by Mirantis. So just assume, so you are new, you'll be having container D. So you'll be having container D as a container runtime interface, as a CRI, container runtime interface. So you'll be having container D. And you will be having another component which is called kubelet, and you'll be having another component which is called kube proxy. Kubelet is the component that keeps on polling API server. Hey, API server, do you have anything for me to run? Hey, tell me, you have anything for me to run? And this also will say, hey, do I need to run anything? And as soon as the scheduler said Okay, hey, this pod needs to run on worker node 1. Immediately, the API server, just a second. Yeah. So immediately API server will say, okay, run this. This is a request that has come. You have to run a pod with image nginx and with so and so spec section. So there will be a spec section that I'll cover in the YAML section. So run this. Now, when the kubelet, how kubelet runs it? So kubelet will talk to the CRI. So kubelet will tell, use the CRI, which is the container runtime interface, and it will tell, I need to run this particular pod. Can you fetch the image? Can you fetch the image from the registry? Can you attach the network? Can you do, then there are like CNI, CRI, CSI, three components are there. So three components which are there, it is called CRI, CNI, CSI. So CRI is the runtime interface, which is containerd. CNI is the networking component in Kubernetes, which is Flannel. I told you this Kubernetes involves a lot of terminology. So keep your brain and mind open and understand. So you need to learn some of the terminologies. That is why I'm going slow over here. Yes, I'm going slow. So CNI is Flannel, Calico, Cilium, and few others as well. And then here is the storage drivers. So storage component is CSI, container storage interface. And the implementations include, so those are the interfaces, the standards. Then they have the implementations, like containerd is the implementation, Flannel is the implementation, Longhorn OpenEBS is the implementation. So then containerd will get the image, attach, whatever the IP, the roots and all that stuff will be there. And then kubeproxy, kubeproxy is another component that maintains the network rules on the node. So in the node, obviously, you need one pod needs to communicate with another pod. One pod needs to communicate with another pod of another node. How to do that? So kubeproxy maintains the network rules on the nodes. These network rules allows network communication to your pods from network sessions inside or outside of the cluster. So it maintains the list of basically IP tables or IPVS. And every time a pod is created, the IP tables is handled by kubeproxy. And you can actually check IP tables -l command on the node that you are running. You'll get the list of those IP tables. So where we are now. So now what it did is, so request came here. Scheduler defined, kubelet said, I want to run, like API server told, kubelet run this particular pod. It talked to the CRI and then used its CNI to attach the network and all that stuff, fancy stuff that it does. It updated the IP tables and now the pod started running. Now the pod is running. So internally, like obviously internally there's a shim that is there, containerd shim, which will be talking to containerd. Then you'll be having runc, and runc actually runs the container. So that's actually the deep dive stuff which is there. So now the container is running, and yeah, the container is running. Now the thing is, this is just a simple example. Where does controller manager comes into play? Now, there are different objects in Kubernetes, which we'll talk all in this workshop. Now, if I want to run 5 replicas of my application, so I will create a different type of object which is there, and that will be controlled by the controller manager. So controller manager is a kind of binary that is having multiple controller managers, like replica set controller manager, deployment controller manager, job controller manager, stateful set controller manager, daemon set. So these are actually Kubernetes objects. When I go to that section, you'll understand what a Kubernetes object is. So these are like this is a pod, right? Like this is a pod. So you can create deployment, you can create stateful set, daemon set, and all that stuff. So controller manager will be controlling that. Your out of those 5 replicas, if your node goes down, your 3 replicas went down, then at least those 3 replicas are spin up on another node will be responsible of controller manager. Controller manager will tell API server, hey, there is a mismatch and I only have 2 replicas ready out of 3. Please create another one. Then again, scheduler will say, okay, this particular node has it and run it over here. So that's how the process goes on. That's a reconciliation loop. So this is the terminology that you will hear often when you are in the Kubernetes ecosystem, reconciliation loop. So that's the reconciliation loop which is there, and your controller manager is responsible for continuously looping through and checking if your desired state and actual state are same. So in Kubernetes, you define the desired state. I want 5 replicas of my application. I want 5 photocopies of my application in very layman terms. Controller manager is responsible for running those 5 copies of your application. Now the last component, which is not which is kind of not the core component, dependent on the cloud. So it is CCM, cloud controller manager. So whenever you I'll cover in the end. So whenever you kind of create a service type load balancer or anything that connects to the cloud, so basically you cannot create a load balancer IP. Kubernetes is not intelligent enough, but cloud controller manager, if your cloud is supporting that, then you can create those load balancer, and cloud controller manager is responsible for talking to the cloud and to the Kubernetes cluster to perform certain actions. So that's very tied to the cloud. That's why its name is also cloud controller manager. So that's your in short the architecture diagram. So it has gone way below, which is fine, no worries. I can anyways delete these. Cool. So that was your Kubernetes architecture. Now you know the complete process of when I run a kubectl, run nginx, what happens, what all components are there in the control plane node, what all components are there in the worker node, and your application actually runs here. This is your application. This is this pod. This pod is your application. This pod is your application. Okay, so this is your application, and these are the components. So I hope I have gone really slow in the architecture. So I hope you understood the architecture of Kubernetes. Just gives a thumbs up in the chat if you understood the architecture of Kubernetes completely. Cool. Let's move on to the next topic, which is YAML. Now, again, I told you it's beginner friendly. It's Kubernetes from scratch, and now the next important topic is YAML, because this is what you will be actually creating. So what exactly is YAML? Let me zoom in a bit. So YAML is a widely used, file syntax in the cloud native system, cloud native space. You have human readable data serialization language. So it is a human readable data serialization language, and it is like YAML and markup language. That is the full form of YAML and markup language. So it's very easy. Indentation matters a lot. Let's try to understand its syntax. So this particular is the example of a pod. So this is the example of pod. Now in YAML, everything is key value object. So here, now don't try to understand what is in the YAML. Just try to understand the YAML syntax, because this particular section is on YAML. So you have your API version and v1. So it is a key and a value. Key and a value. Then this is also key and the value. But sometimes the you need complex stuff which can be represented as objects. So here metadata is the object, and these are the attributes of the object. Next comes the list. So whenever you need to define a list inside YAML, like for example, there are multiple containers that you need to define. So that would be a list of items which are there. So then you have list which is there, and this will be the list items. So how you represent list items? By having a dash. So always remember, like, the two spaces over here matters a lot. The indentation matters a lot. Now this represents that these are part of this object. Now this represents that this key value pair is part of this attribute inside the object. So you need to make sure that your indentation is perfect. So yeah, then you have list item. So if you have another container, then you will put another list and do same image, redis, and name, blah blah blah. So you'll do same. Now suppose you need to write the commands, or you need to write multiple sentences inside a YAML file. So how to do that? So you do that pipe symbol. So you create a pipe symbol for a multi-line string. And another one example is obviously the CA cert file. So this is actually a cert file from Kubernetes. So I'm actually giving you the use cases as well in inbuilt. So you have the CA cert file, and there obviously you need to write the certificate. And now to write the certificate, you need to have a multi-line string, and for that you need to append it with a pipe symbol. Another example can be a pod inside a shell script. So if inside a pod you need to write a shell script, you need to have this particular pipe symbol. Let's go here. Now inside the container, like inside the YAML file, sorry, I'm used to kind of call it container and container. Now inside the containers, first of all, this is YAML. So you do have to focus on the YAML syntax, not anything which is there in the file, because anything which is there in the file will be covered later on when we go to that section, obviously. So just I'm trying to explain you YAML syntax over here. So in this, I want to use the dollars. So you can see I'm using this particular placeholders. So image deploy tag, this is a placeholder for there. And just a second, the screen broadcast has stopped. It should not be a problem. Cool, we're back. So where we were, yeah, and we have to use the dollar sign for the environment variables. And if we want to have multiple files itself, like multiple objects, complete a full multiple object, we can do a separation by 3 colons. So dot dash dash dash, one file can be here and one file can be here. So this will be read separately and applied separately. Cool. So I think that was pretty much, I mean, YAML is not something that I would want to cover in more detail than this, because just a key value, it's a key value pair, very fairly simple to write. These all terminologies you have to learn whenever we move to the next sections. Then what is the object? You just should know, like, okay, this is the object, this is a list, these are the list items which are there. So you should know what all things are there. Cool. Let's move to our next section, which is what is the difference between imperative and declarative commands. So when we were running in the architecture diagram, right? We were running kubectl run nginx -f image nginx. Very simple example we are taking, right? Doing nothing. So that is the imperative command. Imperative means we are doing it via the CLI. That is the imperative command. We are doing it via the CLI. Declarative means the YAML file. We are declaring everything inside a particular file. We are using declarative way of doing things. Generally, imperative would be limited in terms of some things that you can or you cannot do. So you always end up in production writing the declarative file, but that doesn't mean you have to write it from scratch. You can copy paste just like a good developers, or you can do something like dry run and get the skeleton of the application, and then add and subtract whatever stuff which is there. So that's what the imperative and the declarative are. Now inside a YAML file, now inside a Kubernetes object YAML file, there are few things which are common across all the YAML files. What are they? They are API version, that is kind, they are kind, then the metadata section, and the spec section. So the most important part is called the group version resource. You will hear this term. I don't know how much you will hear this term GVR, but GVR is called the group version and resource. So group is the collection of kind, means app, like for example apps is a group, and that group is having different kind, that group is having deployment, replica set, stateful set. For example, instead of pod I have to use deployment, that I cannot use v1, I have to use apps v1, so I have to use apps. So that's how the API version and kind are mapped. Then the version, every group has one or more version, alpha, beta, stable. So v1, alpha 1, v1, beta 1. So all these versions are there. So that you'll be often seeing the alpha features in Kubernetes, beta features in Kubernetes, and then the stable features in Kubernetes. And then you have the resource. So resource is actually use of kind in the API. So whenever you are using like pod, the deployment, so this is the pod deployment, and this is the use of the kind in the API. So that's kind of the group version and resource which is there. Then metadata section. Metadata section will generally contain two stuffs. It contains all the annotations and stuff as well, but we are not going into the details of annotation, though they are kind of important sometimes when you are using ingress, or when you're using some other kind of controllers inside Kubernetes. But on a very high level or a very basic level, with which you can actually start writing YAML, good quality YAML files, you just need labels and name. So they are like bare minimum. So you'll be having name. This is not required actually. We never create this. This is a copy from the dry run. That's why it automatically appeared. So you have labels and the name. Then comes the actual spec section. Spec sections means what actually you want your particular kind of object that you are creating to do. What particular stuff you want from your object of a particular kind to do. I want to create a pod. So that should be having single container. With image called nginx. My container name should be nginx, and that's it. These actually resources are something optional. DNS policy, restart policy are optional. This is optional. These are mandatory. So I hope you understood kubectl run as well. Now let's, okay, when we go there, I can show you the dry run actually, because I know you might be a little bit of bored with the theory, but I'm telling you once again, to all, stick to your laptops and screens. Do not miss any of the things which is there. Okay, you need to learn today Kubernetes. Be with me. Okay, so go to killercoda.com. I'll be sharing the link in the chat. Go to killercoda.com and click on areas. And then you click on playgrounds. And after that, you click on Kubernetes 1.24. Now, it might take a couple of minutes for you, because when there will be a sudden load, there has to be additional instances that will be provisioned in the backend, and there will be some time delay. So you might be seeing overcapacity and stuff like that, but don't worry, this will scale. So I have given the link in the chat, killercoda.com, playgrounds, scenario Kubernetes. If you don't have your account, you can do that. So somebody asked the GVR. GVR is nothing. This is the group. So group is a kind of like the collection of kinds. So in any of the software ecosystem, you have everything defined as APIs. Each APIs will be having different versions, and when you are developing a software, you will be releasing a alpha version of your software first, then beta version of your software, and then the stable version of your software. Now when you are alpha version, then your API version will be alpha, and after that it will be beta. Now in that API version, there can be multiple things, like in your product, when it is alpha, there are 3 features. and when it is in beta, there are 4 features. Or you have different groups. So in Kubernetes, there are different groups which have different kinds and that have different features. So think of it like that. So where we were? Yeah, so I hope you have you are here now. The thing is, why that's why I told you, you don't need like usually the workshops go in a way where, you know, I tell you to create the cluster and all that stuff, but the thing is, now you need to you already have a cluster. So let's first see how to use the cluster. The cluster creation, I'll tell you where to use, and there are like managed ways also to create the cluster. So it is not that complex piece. I know cluster creation is hard and there are big softwares that helps ease out the process, but let's learn Kubernetes first. So this is a Kubernetes cluster, 2-node cluster. It will give you kubectl get nodes. So just run your first kubectl command and give me a thumbs up. Kubectl get nodes. First kubectl command and give me a thumbs up that you ran kubectl get nodes. And it's a big thing, right? You are in the Kubernetes cluster. That's the first kubectl command. Kubectl get nodes. And next command is kubectl get pods hyphen a hyphen capital A. So this will tell you all the pods that are running inside your cluster. This will tell you all the pods that are running inside your cluster. So you are running like this is your networking stuff, this is your core DNS stuff, this is your etcd, this is your API server, controller manager, kube proxy, kube scheduler. So all the components that we have discussed, the major components and the networking pieces, so they are there. That's what comprise of your Kubernetes cluster. That's what I was telling you. So this is your Kubernetes cluster. These are the components of your cluster. And you can actually select, you can see kubectl get pods hyphen a hyphen o wide. So you can actually see, let me clear the screen. And kubectl get pods hyphen a hyphen o wide. So you can actually see the node where it is running. So you can see on the control plane, like the controller manager, API server, etcd, scheduler, they are all running on the control plane because they are the control plane components. They are the control plane components, so they are running over there. It's pretty simple. Now, what I was telling you, kubectl, the first command in the architecture, run, everybody run it. Kubectl run nginx hyphen hyphen image is equal to nginx. Oops. Hyphen hyphen image nginx. Kubectl run nginx hyphen hyphen image nginx. So your pod is created. Simple. Now you do kubectl get pods. I'll tell you, like, we'll go to the pod section, we'll discuss in more details what a pod is. But I just want to take, I want you to take the feel that you are running something. So this is your first pod that you have actually run in the cluster. And you now know how that pod is actually running. So you know the complete architecture. So that's all the communication of API server, scheduler, controller manager, the kubelet, the CNI, the CRI, everything that has done. So here you can see that. Okay, let's move on. Now I was telling you that we can do a dry run client YAML. We actually can get a YAML file. So that's what I meant. So you can do a dry run client hyphen o YAML. So what you can do is dry run client hyphen o YAML. Don't give the same name nginx because you won't be able to create 2 pods with same name in a same namespace. Okay, so just give the name anything and you can try the dry run client YAML. It will give you the YAML file. So it is the same kind of YAML file which I have just shown you. Cool. So let's come back to our slides because That's enough of the demo as well, because I don't want to make you too excited and you are just doing stuff and you don't know what exactly those stuff means. Let's talk about namespaces in Kubernetes. Now you have the Kubernetes cluster. You already have it on your killercoda environments. You have Kubernetes. You have namespaces now. Kubernetes namespaces, there are 4 different types of namespaces which are there. So let's see also side by side. kubectl get ns. So you have default kube node lease, kube public, kube system. So 4 namespaces are there. System, like automatically it means system pods are running in this namespace. So kubectl get pods hyphen n kube system. So we can see the pods in a particular namespace, and to see pod in a particular namespace, just write in the end hyphen n and that namespace. So you can see all the system pods like API server controller, which are the critical components. They are in the kube system namespace, and you should not run your application databases in this particular namespace because that is reserved for the system. Then comes your, let's go to this. So kube system has system pods. Now kube public is containing the, it is not fairly old because I think it came in 1.16 Kubernetes version. It actually tells you the heartbeat of the nodes, and every node has that lease object. So this is having all the lease objects. So we can actually run this command. Clear the screen. kubectl get lease hyphen n cube. Oh, sorry, I told you the separate one, which is there. Sorry, I told you about kube node lease. Kube public is actually containing the cluster info and the certificate data. So kubectl get pods hyphen n kube public. Not the pods, but the CM. I'll tell you what CM is later on, but it contains the cluster info like kubectl on kubectl cluster info. So this particular thing is coming from here. So that is there in the kube public namespace. So the public stuff that is accessible. Next is the kube node lease. Now that was what I was talking about earlier. So kube node lease actually is not very new. It came, I think, in 1.16, and it has the every node has a lease object, so that we can see kube. Did I write that command or not? Anyways, we can type it again. kubectl. You also should know get lease hyphen n kube node lease. So you can see each node is having that lease, basically the heartbeat of the nodes. So each node will be having that, and that is there in the kube node lease. Then you have the default namespace where you are creating your own stuff, your applications. So you are creating all your applications in the this particular namespace. Now these are the namespaces. Now what are namespaces? So namespaces makes your environments isolated. Now for example, let's try to, oh, I'm not in the slideshow view, sorry for that. Yeah, so now let's take the example. Say you have different teams. So you have a dev team in your organization, and you have the testing teams. So you have the dev team and you have the testing team which is there. So each team and each team should have their own quota. Each team should have their own control. Each team should have their own policies. For example, I do not want testing team to use more than certain amount of resources. I do not want the dev team application to be interfering with testing team application. So for example, my so this is my app. This is my app. So my app has version v1. I'm running this perfectly fine. Now somebody testing suddenly changes the image because they are testing something and I don't even know, and they have added to their CI pipelines. Now what will happen? My application is gone. It is their application now. What about my application? So I don't want them to change my application. So I will be running my application in my dev namespace, and they are free to run the same copy of the application with their image in their namespace. So I am happy my workload is running, and they are happy that they are able to test their version of the application. Or if you also want to test the same different version of your application, you can do that in different namespaces. So it provides you the isolated environments where you can have different policies. You can make sure that the dev team service account users do not have access to the testing team service accounts do not have the access to the dev team services should not be able to communicate with the testing team. They have those network policies over there. So you can have different set of policies, different set of quotas in terms of CPU memory that you can define within your namespaces, and each namespace should be used by separate teams and for separate purpose. Now there is secondary reason also for the namespaces. For example, you are deploying monitoring resources, you are then deploying your application, you are then deploying your database, you are then deploying let's say your controllers of a service mesh. So you are deploying multiple things, and suppose everything goes to default and you do kubectl get default, oh my god, so many things appear. So ideally you create a namespace called monitoring and put monitoring components over there, easy to monitor, easy to aggregate, easy to isolate. Put your application in different namespace, uh, your service mesh components in different namespace, your database components in different, so you can have segregation of your namespaces with respect to what you want to deploy on a cluster as well. So don't blindly deploy everything in default namespace. Segregate by namespace so that it's easy to view, easy to visualize, easy to monitor, easy to check, and all those things. So that's what another reason is grouping the resources separately, like monitoring databases, etc. And then it is different, yeah, different version of your application, that is also we have discussed, and your teams. So all these we have discussed. Now let's see that in action. Clear the screen. So first, we already saw kubectl get namespace, but I did ns. How do I know that ns is there? I'll tell you. Do kubectl API resources. When you do kubectl API resources, it gives you the list of all the APIs which are there, and there are some resources which are namespaced, and there are some resources which do not require the namespace. For example, if I do kubectl API resources hyphen name spaced false, I think so, yes. These are the like your volume, your storage class, your nodes. So all these are not the namespace resource, and this is the short name. So this is where I get to know the short name. So either you can do kubectl get nodes, or you can do kubectl get no. So kubectl get nodes, it is not a namespace resource. Kubectl get pods, is a namespace resource, because right now I'm only able to see the pods of the default namespace. So the default namespace is actually the default, where default context as well. Let me give you GitHub Kubesimplify workshop content and Kubernetes 101. Yeah, so we are starting this. Please take a note of this, because all the examples that I will be doing are already present in this particular repository, and we will be performing all the steps one by one. Yeah, I have spent my weekend for you people. Now you just have to stay till the end. So let's create the namespace. kubectl create namespace dev. kubectl create namespace dev. The namespace dev is created. Now let's create another one. kubectl create namespace testing. kubectl create pod name. So this is what kubectl create pod name. Sorry, deployment. Create means create actually means deployment. This won't run FYI. So you have to do a deploy. Just add deploy over there, else it won't run. Okay. And then so you can create the same name of deployment but in different namespaces. Now one I created in default namespace, one I created in dev namespace. How to list all namespaces? kubectl get ns. So I'll be getting all the namespaces, and you can see I created dev 48 seconds ago, testing 45 seconds, 41 seconds ago. I can do a kubectl describe of the namespace as well. So dev, so this will tell you like this was the dev namespace. It has this automatic label that is there. Status is active, no resource quota, no limit range, because we haven't specified any of those things when we have created this particular namespace. Now this was the imperative way. You can also do it in a declarative way. How to get the declarative way is kubectl create namespace demo hyphen dry hyphen run client YAML. So you will be able to see the declarative way of creating the namespace. So API version v1. So it is present in the v1 API version. So v1 is the group, and your kind is namespace, and your metadata is contains the name of your namespace, and you haven't specified anything in the spec section. So spec section can have your quota and all those things. So that's where you will be. This is the declarative way of creating that. Now, in order to delete the namespace, you have to do kubectl delete ns or namespace testing. So it will be deleting the namespace because I haven't spelled kubectl right. That's why it has given this particular error. And it will be deleting all the resources in that particular namespace which are created. So I have actually spent a lot of time in namespace. To be honest, that is more than enough. So if you have understood namespace, please give a thumbs up. Yeah, one last thing in the namespace is switching the context. So right now, if I do kubectl get pods, I see only the pods in the default namespace. But what if I have to switch the context? So I switch the context to the dev namespace. kubectl get pods, kubectl get pods. So I am having now the pod from the dev namespace and not from the default namespace. So if you want to switch your context to different namespace, then you can use this command, or you can use different, fancy tools like kubenes, kubectx, blah, blah stuff, which are there. Now let's go to the next section, which is labels and selectors. Okay, so let me bring it here and zoom in a few of the things because I want to show you. Okay, let's first start with the labels. Okay, so labels in Kubernetes, we can make our objects meaningful. Like it for when you when you have when you go to a restaurant and you have your tea, coffee, milk, hot chocolate, all the big cans over there, then they put a label on top of that, right? It makes it meaningful. It tells you like this is coffee, this is tea, else you don't know what to do. How you will be able to select the coffee, how you will be able to select tea. So similarly, labels can add meaning to your Kubernetes object. So those are the same key value pairs. So drink coffee, drink tea, and here it will be different set of key value pairs that you can define on your particular object. So in this particular example, I did like nothing was there. Then we created a pod in Nginx, and we did kubectl get pod show labels. So it will give me the labels which are there, like these are the labels run in Nginx. They are automatically created. What if we want to label the pod? We want to add a label. So we use a command kubectl label, give pod name, and then our key and value, key equal to value. So key equal to value, key equal to value. Always remember this. Pod is labeled. Again, run this command kubectl get pod show label, and then you'll be having our newly created label over there. And labels are defined in the metadata section. So you can have like metadata, like I told you, there are a lot of things in metadata like annotations. So your CNI, pod IP, all that stuff, they come in the annotation, but that is out of scope of this workshop. But you have labels also that you can define over here. What else is there? Yeah, so now let's go to the selector. So in deployment, like in higher level Kubernetes objects, not higher level, just in some Kubernetes objects, things are selected based on labels. Like if a service, so if I have to send traffic to a pod in a cluster, then I need to know where to send the traffic, and it will happen on the basis of labels. I should know which labels, which pods I actually have to send the traffic. Service will be able to send the traffic based on labels. Deployment, like there are 5 replicas, so I need to know those 5 replicas should have the same label, else I won't know that they are part of my deployment or not. So in metadata, I have this label, and here I have the match labels. So selecting on the base of labels. So these spec will be of the containers. Spec will be of the deployment. So you are matching the label. So in the selector, what you do is match labels. So selecting on the base of labels. Another example, when you are doing selection, now this type of selection is called set based, equity based selection. Also one of the other example is node selector. So you can actually add a node selector, and it will be based on the key value based, which will be equity based. There are other advanced selectors which are like set based labels, which have in, not in, exist. This is a bit complicated concept, stay with me. So this is example taken from the docs. So like this, selector match labels component redis. This is normal equity based. Now second one is match expression. Then is match expression. Here I am saying key operator in values, and then I give the values. Key environment operator not in values. So in, not in. So for very complex operation, I do not think that you will be using it anytime soon, because 90% of the work can be done without this, or you just have to have simple labels. That's it. Simple key value pairs. Let's move on to the exercise for this. So create an image, move to the exercise repository. So labels and the selector, run the image in Nginx. I think this image should already be there. No, because we have switched to dev namespace, so we can create that. Anyways, create that. Then create a deployment in Nginx. I think this is created. Let's label the pod, kubectl label pod. First get the labels, kubectl get pods -- show labels. So you can see the label is there, run nginx. Now label the pod from the next command, kubectl label pod nginx app demo. Now again run the command, and app demo is added. So I'm not lying. So this is how you add the label, and this is how you see the labels added to your cluster. So document will only be given to those who stay till the end. Very simple. So just keep learning. So now we know about the labels and selector as well. Cool. I think Yeah. After this, you can come to the init container section, please, in your file, and leave the above one, because above one is something that we'll do in the end. Come to the init container section. Okay. Cool. Now let's move on with Kubernetes. So till now what we have learned Kubernetes, we have learned pods, we have learned we have learned what Kubernetes is, why Kubernetes, we have learned about the architecture deep dive, we have learned about what namespaces are, we have learned about the YAML file, we have learned about what a YAML file of pod looks like, components, the major components in a YAML file. We have actually ran a particular pod, see the dry run command, imperative way, declarative way, and we have learned what all namespaces are, its use cases. Cool. That's a lot of stuff that we have covered. Now let's move to more action. So these are pods. Now in Kubernetes, anything that you run as pods. In Kubernetes, anything that you runs as pods. So everything will be running as a pod. You want to run a container, but it will be running actually as a pod. So you have your, so this is how it will look like. So this is the pod manifest that we have seen a couple of times now, and you should be aware of it now. So this is the pod. Now how it runs on a particular node. So your node is nothing but a virtual machine or a bare metal machine or Raspberry Pi, whatever it is there. And each pod will be running a container. So your container will be running inside the pod. And you can have one or more containers, which will be obviously talking about the multiple containers and its use cases. Each pod, whenever it is created, it is assigned a pod IP. So there is a pod IP range. Every pod will be getting its own IP. So each pod will be having its own IP. In this particular section, in the metadata section, this is the pod name, and this section is the container name. So this is the pod. Now, what all things we can do with the pods? Let's see that. Clear the screen, and let's kubectl get pods. Let's do a kubectl run. Put your name. I'll put mine. Hyphen image equal to nginx. So pod Saiyam is created. Kubectl get. So these are the operations that I'm trying to show you. So after creating, you can get the pod. How to get the pod? Kubectl get pods. We have Saiyam pod. How to describe the pod? Kubectl describe pod nginx or Saiyam. Sorry. In describe, there are a lot of things that you can actually know. Whenever your pod is kind of not starting, not behaving properly, not scheduling, pending, whatever it is there, this is the first command that you should be running. Like describe it. What is happening with your pod? So first the scheduler scheduled this to this node, then the image started pulling, like kubelet gave the action of pulling the image, then kubelet gave the action to start the creator, then it started the container. So it tells you all the events that has happened. It also tells you the toleration, that this does it have any toleration or to go against the taint. Then it also tells the quality of service class, which is its best effort. I will not tell you about the quality of service class because it has scope out of the scope of Kubernetes 101. Then you have mounts. What all mounts are there? So this mount is a service account token with which you can actually interact with the Kubernetes API server from within the pod using this token, which is mounted inside every container. Then it gives you the container information like container ID, what is the image, the SHA, whatever is there. Then you have the host port, what is the state of it, is it ready or not, what is it restart count, like if it went out of memory. Then also the IP, so it tells you the IP of that, annotations that got added. So what happens is our annotation is getting added as part of the mutation, the webhooks which are there from the uh, Calico project. So Calico is just another CNI, and that's the functionality of it, that it is adding the annotation. So you don't have to worry about it. You don't have to take care about that. So you should be describing, and then it also gives the name of the pod, namespace, and the node where it is actually running, and the labels as well. So it gives the complete description of the pods. The next step is there that whenever you create the application, you see the logs of your application, right? So similarly, you can see kubectl logs -f is to follow of the pod. So I can just see the logs of my pod as well. So whenever any new request will be there, there will be logs for this. So this is how you see the logs of the container. What other action you can perform is kubectl get pods. I can delete a pod. So kubectl delete pod in nginx, the pod gets deleted. You can see the exec. So let's clear the screen. How to go inside the pod and see what is happening. So kubectl exec -it, same as the docker docker exec. So kubectl exec -it, then the pod name, and then hyphen then sh, the shell. Some has bash, some has sh, and you can see it has its own file system which is there. You can do ps, whatever stuff is you can regularly do, like cat, what is there, and go to different directory user, you know and then you can exit the pod, then kubectl get pods. Last thing, yeah, you can do kubectl get pods -o wide. This actually gives you the wid. So this gives you the wider view, not only the age, so it adds more information, ip, node name, and the other stuff which is there, so nominated, etc. So you have the readiness gates, all this stuff, so it gives you extra information about your pod. And one last thing that you can do with pod is actually you can do it with any of the sources, is kubectl delete pod Saiyam -force. What happens is, whenever you delete a pod, there is a termination grace period of a particular resource. So that termination grace period, I think, is about 30 seconds. So if, for example, just a common scenario, right, try to open up your mind. Whenever a request is coming, whenever you are hitting a request and you suddenly put a delete command, you at least want that request to be processed, and no other further request should be there. So that particular termination grace period, if it is serving a request, then it will be served for 30 seconds and then it will be deleted. Things like that. So that is what is pod is. So you have I hope you just have done the pod. I'm not sure if I have entered the basic pod examples, but from now on there will be good examples which are there in the in that repository. But pod, normal pod, right? So I have, like, you yourself have created the pod with using imperative way now, like for now, like 10-15 times. Exit. So just press exit and you can come out of that exit. I will add those same commands if you want here. Anyways, let's go to our notes again. Next is the pod lifecycle. So whenever a pod is created, everything has a lifecycle. So pod also has a lifecycle. So whenever a pod is getting created, the first step that it goes to is called pending. So pending is a state where actually the scheduler is trying to find the node for it. Because let's say you give n number of resources, and how will, if there are no nodes only to cater your request, then your node will always stay in pending. So it is basically finding the node. Or let's say you have created a node which has a storage attached to it, like persistent volume or persistent volume claim. So your node will stay in pending till your PV and PVC are created and bound to each other. So that is the first stage. Second is the container creating. It means like pulling the image from the registry. So CRI is pulling the image, then starting it, then CNI is attaching the network, and CSI is getting the storage stuff attached to it. So that is the container creating phase. Then running, we already know. Error, if there is some error in your code, it errors out like the exit one, whatever is there. Crash loop, back off, process dying too many times, like out of memory, or your process just whatever you said is completed, but you're again running it. So crash looping, back off, because Kubernetes has the ability to keep your container running, but your processes are still in your hands. Then it's succeeded. So completed are there when your work is actually completed, like in jobs, etc. So when your pod work is completed, it is completed. So that is the pod lifecycle. Now you know about containers. You know about containers. You know about pods. I was telling you, that when you are running a pod can have one or more container, C1, C2. A pod can have one or more container, which is actually the next topic, but it is worth to mention here because init container is also another another container only. So what happens is, but init container is a special type of container that runs before the main container. So it has its own use cases. It's not just like that it is there. It has its own use cases. So it runs before the main container. Main container is your application container. Init container will run before the main container. It can contain the custom code that is not present in the app. So you can have some custom code which you want to run before your main container. You want some file system to be changed, or some files to be created, or some files to be added with something before your application container starts. Then precondition checks. Maybe you want to check if certain services are running. Maybe you want to check if any of the things which are there, the preconditions for your particular container. And it will run in sequential order. So if you have you can have multiple init containers. So you can have 3 or 4 init containers with specific jobs, and there are people use like 2 through 3 init containers before even starting their main application, because there are multiple stuff that you need to actually have ready before your application container runs. So those can be in the init container, and you can have multiple init container. If you have multiple init container, then it will run in sequential order. So that's the screenshot of the container. So you can see the init container which will be there. So here you have 2 containers, but we'll see that in action anyways. So let's go to the workshop. This is the init container one. Let's copy that, do a vi of init. So now here kind is pod. In the container section, you have name, image, nginx, port. I have given container port as 80, and it is mounting a volume. So I'll tell you now about volume as well. But first, let's move to the init container. So init containers are specified by typing init containers. So camel casing is there. Okay, init containers. You give the name of your container, the image. I have chosen busy box, and the command. So if you want to write a command in your container, if you want to write a command that you want to run inside a container, so you will be writing command, and then you'll be giving wget o, and I want the output in this particular location, and then of kubesimplify.com. And then it is a volume. So volume in Kubernetes is something, especially the empty dir. Empty dir is just the empty directory. Just understand this for now. Empty dir is the empty directory that is created on your node system. The node, it is not inside the container. That volume is on the node. So that volume is on the node, empty directory. It's not nothing is getting created, but it's empty. As soon as the container goes off, your empty dir also went off. So it is actually in the container where run whatever the container path which is there, and there will be the directory. Now that's how we define volumes. In order to define volumes, you just say volume name and give a empty dir. So this is the one type of volume which is there, local volume. And when you want to mount that volume inside the container, you will be using volume mounts. I want shared volume to be mounted inside this container at this path which is /shared. I want this volume to be mounted inside nginx container as volume mounts with the name shared at the path user share nginx html. So what we are doing basically, we are getting wget of our Kubesimplify file. We are storing that at slash shared index.html. Now since this is init container will run first. Init container will run as first container. Now this will create this particular file, and this is mounted on as empty directory, so it is slash shared. So slash shared has now index.html. Now what we want is this particular stuff should be there inside the user share nginx html. So whenever nginx starts, instead of the default welcome to nginx html, our html should be this. So that's what I was telling. This is a use case. Escape :wq kubectl apply -f init demo created kubectl get pods -n default kubectl. You can see where it is created. Oh, it has created in this. Sorry. Init demo. So init demo is running. Now exec into the pod and curl localhost. Okay, kubectl exec -it init demo 1 --sh curl localhost. So you can see it is not the same HTML file. It is proper the Kubesimplify HTML file which has come as over here, which is serving. So you can see hash node, and you can see we are actually using hash node behind kubesimplify.com. Perfect. Control C and then do exit and then clear the screen. Let's go back. So we learned about init containers. Init containers are special type of containers that run before your main container, and you can use the similar use case. You can mount some volumes, and you can change the file system and use that file system inside the main container. I gave you a proper use case and the example as well. You can have multiple init containers. They'll run it in sequential order. Now the multiple containers. So multi-container, again, by now a single pod can run multiple containers. By the way, just to tell you one interesting fact over here, whenever I told you, whenever you create a pod, it gets a IP. But what about two containers? So pod will always get single IP. Containers will share. So containers share the namespaces, share the IP. They talk with each other on localhost. So they talk to each other on localhost. Okay, multi-container. So multi-container has its own use cases. Why you want to have two containers, C1 and C2? Just run one container per pod. That is a good practice. That is very good. But sometimes there are use cases where you need to run multiple containers, like the sidecar patterns. Like you need to have envoy proxy as part of your containers. You need to have log. For application logs, you want your other containers to fetch the logs and store it somewhere. You need to act it as a reverse proxy to host static files from the main container. So you need second container to get the static files and then host it. You need to send out the network traffic using the envoy proxy and stuff like that. So for these kind of scenarios, you will be having the multi-container pods. Let's quickly see the example of multi-container pod. Very good example. I hope it runs. So vi multi, and then let's see what this example is. Let's go here. I can actually show you from here. So what this pod does is, this is a multi-container pod. How to specify multi-container pod? In the spec section of the pod, you define containers. I told you containers has a list, and these are the list items. So you have 3 containers over here. So you have init container. So you have multiple containers. You have 2 init containers. Oh, sorry. That is okay. We'll run this anyways. Let me just get the multi. So this is not a multi-container example. Actually, this is, but not that multi-container example. This is multiple init container example. So init containers is still not over. So multiple init containers. So now in this particular application, like I was telling you, you can have multiple init containers as well. So this is the container, app container. So this is the busy box container, and it is just doing a sleep of 3600. So it is the sleeping container, and 2 containers are there. 2 init containers are there. First is init service, then is init my db. What each of them are doing? So until ns lookup, and I am trying to call the local service and this particular service. So how to call a service is actually kind of simple. So I told you that there's a token which will, you will get the namespace from that. So this will give the namespace. So default dot svc dot local cluster dot local. If it is there, then it is success, and again if this is there, then it is success, and if both are success, then only our app container will start. So I was telling you one of the use cases. If you go back, if you have heard properly, if you have heard, come on. So init container, so if you have heard properly, that it has certain changes, certain checks, precondition checks. So precondition checks if certain files are there on the system. So if certain services are there on the system. So if certain services are present, then only start my container. That's a very valid use case. So now apply this particular YAML file. I hope it works. Apply -f multi. Okay, init demo2 created, kubectl get pods. There you go. Now you are able to see the fancy state. Init 0 out of 2 means none of the container is ready. Means none of the container is ready. What happened? None of the container is ready. First step that you do is describe pod init demo2. It is saying that I successfully pulled. I have created the init my service, the first init container I have started. But after that, unless and until the init container finishes, the main container won't start. So now let's create those services that we said we will create. So if you go back, you have svc. Don't worry, services you don't need to worry, because I'll cover it later on. But first you need to create those in order for this particular demo to work. Error validating API version is not there. So folks, oh no, it's correct. I added additional I. Yep. So both the services are created. Now let's do kubectl get pods. We can see, we'll slowly see that it will start. Hopefully. I hope I have given the names right. Let me go here. So DB service, and app service. Yep. So it took a little bit of time. kubectl get pods. kubectl get pods. So you can see now the pod is running. So both the init containers were successful because I created both of those services. This is another use case of init containers. Now let's move to multi-container. We have already understood the theory. So let's do the practical. Copy and paste the multi-container pod. So vi, let's name it mc.yaml, and paste it. So it is a multi-container pod. Again, we have same kind of empty dir volume that I explained earlier. In the container section, so how to define multi-container pod is in the container section, we have a list. So first is Nginx container. It is again doing the, you know, mounting the shared data, this empty dir to user share Nginx HTML inside the container. So from shared data on the node to user share Nginx HTML in the container. Second one is the Alpine container. Alpine container is mounting the shared data onto mount path / mem info. So both the containers are sharing this particular directory because there's a purpose for that. Command. What command it is running? It is running bin sh-c and arguments. In arguments, it is running a script. While true, date, adding the date to this mem info, see mem info index.html, and then reading the proc mem info and adding that also to the index.html. So that's a very simple bash script. Let's apply this kubectl apply -f nc dot mc dot yaml kubectl. Multi-container pod is created. Get pods. Container is getting created. Let's wait. And here now you'll be able to see 2 out of 2 instead of 1 out of 1 because both of the containers are running perfectly. That shows both of our containers are running perfectly. Now let's see the logs. How to see the logs of a multi-container pod. So kubectl pod multi-container. So we can see 2 containers are here if we describe. So container 1 is Nginx container. Container 2 is Alpine container. This one. Now let's see the logs of Nginx container. So kubectl logs -f. This after this you give the container name -c Nginx container. Oh, multi-container pod. Multi. So you can see these are the logs of this. But we want to look at the HTML file. What is happening over there? So now you do kubectl exec. So this is another way to do the command. Kubectl exec -it and just do a curl localhost so that we just know what all things are there in the HTML file. So you can see the timestamp. So this is 15:38:16. Now let's run again. This will be 15:38:22. So every 2 seconds, the memory /proc mem is getting added to the HTML file and you are able to view that. So that's one of the use cases of multi-container pod. And I hope you like the example. If you like and you have done till now, hit the thumbs up. Come on, you don't have to slow down. Things are getting started. I know things are uh, getting complicated, but it is important for you to learn it, because why I'm giving these examples, those are the actual use cases. Those are the use cases that you should understand. Simple pods. This is not a any Kubernetes workshop, right? It's a workshop that I have prepared. I want you to understand what a pod is, what are init containers, what are multi containers, how to run them, what are the uses of init containers and multiple init containers. So you should have those real kind of examples in front of you so that you can understand, oh wow, this HTML file, this is mounted onto the node, this is writing to this index HTML file, and then Nginx is again mounting that Nginx HTML file in its user share Nginx HTML. So that's where you are getting that value for. One is getting writing the mem info, another one is getting it in the HTML file. So I think those are the use cases which are there. Let's move on. So we have learned pods, pod lifecycle, init container, multiple init container, multi-container. Now let's look at a very interesting topic, which is probes. Probes are, now open your brain, okay? Try to understand. So container probes are something which you apply to the particular pod. Now, for example, say you have a pod. Let's take like you have a pod, and via a service, you are sending the traffic to this particular pod. Okay, you keep on sending the traffic, and what if the pod itself is not ready to handle the traffic, or something has happened that it is not like suddenly there's a burst of requests. This particular pod is not able to handle that much amount of traffic. I know scaling is there, but this pod, due to some reason, or maybe one of the file got corrupted, maybe one of the file got deleted, maybe someone tampered with your container, and something went wrong where this pod is ready, but it is not ready. It's not ready to take the traffic. Kubernetes doesn't know that. Kubernetes will keep on sending the traffic. So Kubernetes sends the traffic even if the pod is not ready to handle it, because it doesn't know. Another example is deadlock situation. So what if there is a deadlock situation and Kubernetes still starts sending traffic? Like you have a complex database which is there, and like in databases you have read the concept of deadlocking. So what happens in that particular deadlock scenario? Your deadlock won't be able to identified by Kubernetes, and Kubernetes will still be sending traffic, and it will lead to inconsistencies, it will lead to data inconsistencies, it will lead to not giving proper output to your application. So for these, there is something probes that you can define inside your pods. There are three types of probes: readiness probes, startup probes, and liveness probes. So readiness probes check if the pod is ready to accept the traffic. Very simple check the dependencies for the pod in terms of availability of the service or latency. So there can be latency issues, right? There can be huge network traffic issues, so it can check that maybe a particular port is open or not, maybe particular /health endpoint is I'm getting the response or not. Startup probe is, so let's first do liveness probe is http get. There are three types, like http get, tcp socket, and exec. If the response is okay, then it is okay. If tcp socket is a port, check if the port is open, then it is okay. Sometimes there's a port not open inside the container. What happens? The Kubernetes won't know, but in liveness you can do that. And exec, so that can be the custom conditions, custom command, like file check, just like we did, right? File check. So it can be a custom command to check if the pod is ready or not. Now kubelet restarts the container whenever the liveness fails. So whenever a liveness probe fails, kubelet will restart the container. Now startup probe is a special type of probe which executes first, and until this probe is successful, none of the other probes will start running. Now the misconception probably, or the wrong usage, or the whatever I have seen in my experiences, people start using the readiness and liveness together, and they exactly give same information over there. That actually isn't helpful, quite helpful. So they are there for specific purposes and should be used for specific purposes. So you can also define the initial delay seconds, like how many delay should be there before even running this probe. You can give the timeout, like what is the timeout period that it should be, like before kubelet receive the response from the liveness, startup, or readiness probe. You can see the period, like how much often you should be, like the kubelet should be, the probe should run basically. And you how after how many times you should consider it a success, and after how many times you should consider it a failure. So after so let's say http get fails 3 times, then only the pod gets restart. Okay, and when it passes for 1 time, then the pod will start. Just hold on, my screen share went off, so I need to reshare. 600, yep. And we are back. Yeah, we should be back. And let me do a bigger size screen. Cool. So where I was. Mm, yeah, so we have three probes: readiness, startup, liveness. They have their own specific purpose to check the traffic latency issues, then go for readiness. If you have like direct http get tcp socket exec, you do liveness and startup probe, a special type of probe. If you want any additional check that you want first, just only that check, and then other things, because after after startup probe it won't run again. After startup probe, only readiness and liveness will keep on running. You should understand that. Like if you want a probe to run just once for a file check and then just disappear, and then other probes to keep on running. Let's see if any workshop has that. Oh, nice. So workshop, I have a example of container probes. Copy that. Go to the playground. So the playground is deleted. So let's start again, because it's I think 1 hour since we had the playground. Let's start again. By the way, thanks. Huge shout out to killercoda and Kim. They have been really helpful with the workshops. He has pre-provisioned a lot of things so that we all can do the labs peacefully. So create the container probe and install. Oh, sorry, copy, paste. Okay, so kind pod spec. In the spec section, you have containers. Now in the container you specify the probes. So liveness probe http get port 80. So if I am able to get http port 80, means the container is able to take the traffic. So kubectl create -f cp. Nobody asked me the question. Sometimes I'm doing kubectl create, sometimes I'm doing kubectl apply. Why I'm doing like this? Nobody asked this question. Why you haven't asked this? I'm intentionally doing this so that you'll ask once. So basically what happens is kubectl will create the file once. The apply will just apply the changes on top of that. So if you have created once, you won't be able to create again, but you will be able to apply. So you create once and then keep on applying the changes. So it's like you can always do an apply, that works. But if you want to do fancy things, you can do create also. So kubectl gets pods. So you can see my container is running. Kubectl describe pod. I can show you that the liveness is there somewhere. Yeah, you can see the liveness section is there. So let's go to the workshop. It says the demo with the path demo for failure and changed http get to. Okay, what that means is instead of slash, do a slash demo. We know that demo is not there. kubectl apply fcp. kubectl. In pods we cannot change actually, so we need to delete this. Kubectl delete. I should have done force. Anyways, and apply it. Pod is created, it will fail. Kubectl get pods. It will fail after some time. Kubectl get pods. And soon after 30 seconds, I believe so, because we have 3 checks and each check is after 10 seconds. Container is starting, container is doing. Now it's not the readiness check which is there, it's a liveness check. Okay, another thing is you can do kubectl get pods -w. Okay, you can now see a restart. So you can see one restart. You can see one restart. Now let's describe this. Kubectl describe pod nginx. You can see liveness probe failed because that is not there. That 404, that slash demo is not there only. So that was one demo. Now let's change to TCP socket. you can do that actually. So you can change like TCP instead of HTTP get path, you can just check for port. So whether this container port, because we know container port 80, right? So in TCP check, you can do a port 8080, it will fail. And if you do port 80, it will be a success. Ooh, next demo is interesting, and I don't have theory for that. Are you ready for next demo? Okay, what we'll do is after this demo, we'll take the break and it will take 10 minutes to complete this demo. So let's go to the playground. I hope you are, by the way, clear, this probes. Okay, probes are important. Now things will get interesting. So stay with me and keep learning. Here. So when you go to the workshops, you can apply this file, whatever is mentioned over here, kubectl apply, copy till here. I'll tell you what it is applying. So we are just creating a metrics server. It's a metrics server that we are deploying onto the Kubernetes cluster. So it creates a lot of components: metrics server, cluster role binding, service deployment, blah blah blah. Good. Kubectl get pods -a. Soon that will be running, and it's almost running. Yeah, it is not running. Yeah, so it won't run, by the way. Wait. Don't apply that. I forgot one thing. I have mentioned in this also. We have to change this flag. So what you do is copy from here, HTTPS. Copy from here, HTTPS. Go till the end, and first you do kubectl delete -f. Kubectl delete -f. This, so first delete all components. Now curl -o, get this particular file and go inside that. Okay, let me get the raw file. It gives me the file. Okay, don't do curl. Can you do a wget? Yeah, do a wget instead. So do a wget and you'll get a file. pi into that, and scroll down and come to the section where you have these flags, metric server flags. In the end, you need to just add this flag, kubectl insecure TLS, because we don't have that authentication mechanism as of now. So add a hyphen and hyphen kubectl insecure TLS. Have you seen this? Vi, scroll here, hyphen, and two hyphens, then kubectl insecure TLS. Save it, apply it. Yeah, now let's see kubectl get pods. Our metric server should start running, I believe so, in some time. Come on. Yep. So finally, our metric server is 1 out of 1. So that's what I was checking actually. Cool. This is done. Let's move on and copy this particular file. And now I'll start explaining you rr.yaml resource request, what that is. So basically, in any of your components, in any of your files deployments, you can define the resource and request. So it's very important to define resource and request for your particular pods, because if you want to use the resources efficiently in your systems, you should be using the resource request and resource limits. So resources, the object name over here is resources. Resources has two, which is limits and request. Again, limits has 2, which is CPU memory. Request has 2 CPU memory. What does request mean? Request means I am requesting this much resource minimum for my pod. I am requesting this much resource minimum for my pod. But on the limit, I do not want it to go beyond a particular limit. Okay, I do not want it to go beyond a particular limit. But yeah, CPU, yeah, correct. So run this kubectl create -f rr. I'll show you one example. So kubectl get pods. Oh, you can set up aliases. Oh my god, so many times. How can I do bad? Okay, it's running limit test. Okay, kubectl is running limit test. It is fine, right? We can check with kubectl top pods. Matrix is not available. Anyways, it's be available. Okay, let me delete that in the next one. Anyways, what I want to show you is kubectl top nodes. Yeah, so kubectl top nodes show me the CPU and memory. So you can see the CPU cores which are there, one CPU, and control plane is this much. And what we are asking over here is cat RR. So we are asking 500, I believe. Yeah, 500 we are asking. And here we are, but in the command line argument, we are stressing on 2 CPUs. So we have a limit of 1 CPU. We requested for minimum 500, but we are running with 2. What happens in this case is it will throttle. So even if we are asking for 2, the limits will stay under 1. So let it generate the metrics and we'll do another example. So vi into RR and change the name to limit test 2 because you cannot create the same name pods. Change everything to 3. Change change your CPU. I mean CPU to 3, CPU to 3, and CPU to 3. Change everything to 3. kubectl create -f. Now this will be very good. kubectl get pods. It will always stay in pending. It will always stay in pending. Now, why it is staying in pending? Let's clear the screen. kubectl describe pod. What was that name? Limit test 2. What the name? kubectl get pods. Name is limit test. Okay, -2. So kubectl describe pod. You can say that 0 out of 2 node insufficient CPU. We don't even have that CPU that we are requesting. We are asking for 3. No. We cannot ask for 3 because 3 is not there only. So scheduler is not able to find a node. So that's where the intelligence of scheduler comes in. Scheduler said, I do not have any node. Where will I run this? So let's be it in pending, or you add some node over here which has this capacity. Now let's do kubectl top pods. And you can see the limit test is not going beyond 1. So even if we specified 2, we requested for 500, but inside the our container arguments we are running 2, but it is getting throttled. So CPU got throttled and it is below the limit that we specified. So it is always below 1. So I hope you understood the concept of what did you understood the concept of resources. And now it's 9:30, perfect time to take a 15-minute break. And we have a lot to cover after that. Very interesting section. So till now, what we have covered, by the way, we have covered Kubernetes architecture. Let me show you. Let me go back above. and if let me make you feel happy that what you have covered. So you have covered actually introduction to Kubernetes. Cheers for you. Always keep on clapping. Pods, keep on clapping. That's it. I mean, it's okay. It's okay. We are going there. Now it's not that much left because uh, those are now easy for you to understand, because now you understand the concepts of Kubernetes. You understand the the concepts of YAML files. You understand the concepts of resource limits. I wanted to make the base clear. Now your foundations are perfectly fine. So your foundations are clear, and now we will be able to cover these very quickly, just like this. So when I return in 15 minutes, just like this, we'll cover everything. I know you are with me and you trust me. So we'll be back in 15. It's 9:30 p.m. IST, and I'll be back at 9:45 p.m. IST, which is 9:15 a.m. PT. So in 15 minutes, see you. Okay, so we are back, and I hope you are enjoying the workshop and you are practicing something as well. The demo repository is there, and the demo repository will be there. So make sure to even practice as much as you can, so that you can create, run applications, and do a lot of things in with Kubernetes, because the next set of workshops is built on top of Kubernetes. Like, it will teach you more advanced concepts, GitOps, troubleshooting, chaos engineering, and all those fancy things. So this is the previous one was the extreme foundation, the Linux and Docker. This one is the core foundation, and that's why I wanted to spend more time on the Kubernetes pieces, so that you have good understanding of Kubernetes. And the next time, all those who have attended this workshop should not say that they don't know Kubernetes. They should always say, I know Kubernetes and I know it deep dive. I know all the concepts. I know about, request, limits, init container, multi-container. You ask me in namespaces, what a YAML is, anything you ask, I know with use cases. So you need to tell that, like, you know things, with the use cases, with the examples, and you have practiced that. So that's where you kind of need to grow. Okay, so it's 9:45 and we are back. Welcome everyone back, and thank you so much for staying till here, because the next set of stuff is going to be even more exciting. I have kept networking till the end, so the networking has demos, and the demos will be nice, and I'll show you a lot of good stuff in the networking pieces. Cool. So let me take some questions if there are. So one question was the HA. So Kubernetes doesn't know about HA. If you want to spin up the HA kind of cluster, then what you need to do is you need to have 3 control planes. So 3 control plane nodes, which will have 3 etcds. Etcds actually can live outside of the control plane as well. Oh, let me do this version of the screen. Yeah. So 3 control planes, and then as many number of worker nodes you would like to attach to that. So you can do that. Fun fact, the by default limit per container per node is 110. Fun fact 2, you can edit that. So yeah, so they are not HA aware. And what about, there was one more question. Init containers. Okay, yeah, init containers are very simple. Init containers, let's go there. So init containers, just they run before the main container. So I gave you the example where you were checking for the files before they exist, checking for the services, they are up or not, and then only you start the main container. Because let's say you are starting a main container and they are requiring some services to be there, your container will fail. So let's not even put that in running state, and have it have some checks for that, and then it will be there. Requests, so requests are something that you are requesting from when you are creating the pods and the deployment. So you are saying that for this particular pod I need to have the requested CPU as 500 and requested memory as 100, but I do not want them to use more than one CPU. And this is a stress test, so don't go to the commands, they are just for the example. You need to focus on this section. So defining the resource limit and resource request. There are interesting takes, to be very honest, because I told you, I only gave you the example. Even if you specify the resources, even if you specify the request, you can still try and use two CPUs. So you can still give that. So basically it's no kind of, but you still give the upper limit. But if you have the, what you call, so you have the upper limit over there, and don't go over there. Yeah, I was saying there are interesting discussions with respect to request resource, whether they should be there, should not be there. I recommend you reading that and decide on your own. Okay, now we have to do deployment. Any other questions? Thanks, team. Okay, RBAC, we are not yet there, and I probably won't cover that deep dive because RBAC is way too much to explain. But I'll tell you a few of the stuffs for sure. I'll at least cover the authentication, authorization, and admission mechanisms. That is for sure. Any other questions that were there? Just let me check. I think I answered most of them. Yeah, there was like when they designed Docker, they did not think about scale. See, Docker came in very initially, and it also had its container orchestration system, which was Docker Swarm, very easy to spin up, but it was not meant for scale. And that's the only stuff. And they were not able to create that scale for that. So I think you can say they failed over there. And but because of Docker, we are all here, to be honest. Cool. Lease and heartbeat are nothing, just the new concept which is there. There's nothing much to know about that. There's a namespace cube node lease that keeps a config map. Sorry, each node has its own lease. It's not nothing fancy over there. So I can show you cube node lease. So you can see, so this is the enhancement proposal that gives you the summary of node heartbeats. So node heartbeats are necessary for correct functioning of Kubernetes cluster, and this makes them significantly cheaper from scalability and performance perspective. So you can see what all things are there. Graceful shutdown, lease, what is the lease, and the struct type. So if you want like a deep dive, you can go through the enhancement proposal. But it's newly built. I think it became stable in 1.17. By the way, we are running in today's date, we are running 1.24. So all the clusters that you are running is Kubernetes version 1.24. Yep, I hope I have answered all the questions. Now let's get back. Yeah, I was just waiting for 100 viewers. So. Yeah, but I think 25, 30 people dropped. That's very bad. You need to stay till the end, okay? So keep sharing as well. That next stuff that you are learning is deployments. So let's come to deployments. So now we know about pod, but a single pod, when you are deploying a single pod, what happens when the pod is deleted? It goes away. What happens that if a node is deleted, your application goes down? So we need a true power of Kubernetes. We need true power of Kubernetes, where if a pod goes down, then Kubernetes should automatically create that pod. If a node goes down, then Kubernetes should shift all those pods to some other available node. If we say we need 5 copies of our pod, then there should always be 5 copies of our pod. So we need that power, and we need Kubernetes to manage that. We don't want to manage that overhead. That's why we are using Kubernetes, right? We are learning so many fancy concepts, and Kubernetes won't do this much for us. So yes, Kubernetes provides an object called deployment. Deployment is a Kubernetes object that creates the internally that creates the replica set. So often you will hear about replica set, which is handled by replication controller, and this replicas set purpose is to maintain the replicas of a particular pod. Replica meaning photocopies. Just say like you have you go to a shop and say give me 5 copies of my photo. So that's why. So those 5 copies, so replica set maintains that, but you never directly create that replica set, although replica set is also a Kubernetes um, object. So it's a kind replica set, but you never create that because you always deal with higher level abstraction, which is deployment, because you can do much more with that. You can define the strategies, you can define replicas, you can define many things over here. So this particular deployment, if you see, so it is a deployment kind. We have some labels in the name. In the spec section, this is important. We define replicas. How many replicas, how many copies of my application I want to run in Kubernetes. So I need to, how to select those, select based on the app nginx. So all the pods that will be created, they will be having the label called app nginx. What is the template of your pod, which looks like? So that template will be having the spec section that actually defines the containers, the image, the name, and the resources. Again, these resources we just covered above, the request and the limit. So this creates 2 pods. So if we see a Kubernetes kubectl get pods, it will create 2 pods. Now, what happens when, so now you created this particular pod with nginx image, but your application keeps on changing, right? You keep on releasing new version of your applications. What happens then? So whenever you want to update the application, when you update your deployment image, a new pod gets created. So there will be a new pod that gets created. Service stops sending the pod to the old pod. So let's consider it this way. So you have 4 pods. So you have 3 pods, 3 replicas. Now you change the image. You say, I need a new image. Kubernetes will create 1 pod and will start sending traffic to this and will break the link for this pod. Now when it does that, it does not it first make sure that it's healthy, obviously the readiness, all the probes, etc. check which is there. So this becomes healthy and this starts sending the traffic to this, but this immediately doesn't go away. It has certain grace period, which is called the termination grace period, which I told you earlier as well. For example, it is already serving a particular request and it has to complete that. So it will complete that particular request, and then this particular pod will be created, and then similarly another pod will be created and this link will break, and another pod will be created, this link will break. So this is the rolling update strategy where your application never goes down and you have changed the image as well. So you can define the strategy. By default, the strategy, the rolling update strategy is 25% max unavailable and 25% max search. Max unavailable means how many pods you are saying can remain unavailable. So like say, 3 are there, then out of which only 1 remains unavailable and 2 should always be available. Max search, how many pods you can extra create. Like if I give, let's say 100%. So I am saying that directly create 3 pods. Max search means the new replicas that you create, how many? So that's also 25, then it will create one by one. So that's by default. Strategy type is rolling update, and min ready seconds is again how many minimum ready seconds it should wait after new pod spins up before it sends the traffic to that pod. These are important from the deployment perspective. Oh, sorry, you should know all these details. So you should know all these details. So that's what a deployment is. Let's try to understand it. Let's try to create a deployment and see how it looks like. kubectl. Let's clear the screen. So let's create kubectl create deploy nginx -image is equal to nginx. So our deployment is created. How to get it? kubectl get deploy. I told you deployment internally creates replica set, and it internally creates pods. So you can see the deployment is Nginx. Then it adds the replica number, replica set ID, the random hash, and then it adds the deployment hash. So that's how the name comes. So that's how the name comes. So kubectl, and same like kubectl. What all we can do? We have this logs is logs from the pod. You can take, you can do all that stuff. Yeah. So we wanted to change the image. But first, let's scale it. Let's update the replicas. So kubectl scale deploy nginx hyphen replicas 5. Now I will be having 5 pods container creating. Change this name to Nginx. Okay, it is written S over here. So if you are directly copy pasting, make sure to change this name to S, and then you run the next command. Now, so till now, what we have done, we have created the deployment. We have scaled that using the command. If you haven't seen, because I haven't put that command. So that command is called kubectl scale. Kubectl scale deploy Nginx hyphen replicas 5. Don't worry. What you can do is kubectl edit deploy Nginx. You can edit it on the fly. So you go edit, you go in the edit mode, you go to the replicas, and you make the change 3, and you save it. So it is edited, and you will be able to see 2 pods are terminating, and there will be now 3 replicas. So either you can do by kubectl scale, or you can do by kubectl edit deploy. Now let's run the command which I have mentioned on the workshop to set the image. Now I was telling we need to change the particular image. I'll tell you why also we need to change this. So we can update, set the image, deployment Nginx, and change the image to Nginx 115.2. So kubectl get pods, you will be able to see pods are terminating and creating, terminating and creating. But if I see kubectl describe it, deploy, I'll be able to understand more clearly what is actually happening. So you can see, first I scaled up. So scaled up replica set, scaled up replica set. Then we scaled down the replica set, scaled up replica set, scaled down replica set. After that, one by one, the pod goes. So 1, 2. So it is like 1, and then 2, 5, 3, 1, 2, and now it will be 3. So kubectl get pods, and 1 is still creating. So it will be creating soon. So you can see that we have all this running, running, running. Why we still have another one? Because this is still container creating. That's why this is 4. So that's the search. And yeah, this is the rolling update strategy. Search. Okay. Replicas are 3, 2 are updated, 4 in total are there, 3 is available, 1 is unavailable. We are able to see that. You can see the image that I have changed. I have changed the image to 1.15.2. Now, let's change the image to the next Saiyam. And now if I get pods, it will say container creating. Okay. And nothing will happen. Only 1. Now, sometimes you can give a wrong image or some bad image or something that it goes into error stage. So your traffic doesn't get hampered. Your all previous pods are still running. And this is one new pod that created, it failed. So the deployment has stopped. Nothing is happening. And what you actually can do is you can see the kubectl rollout status nginx deploy, waiting for the deployment. So if you want to see how many replicas have been updated, you can use this command. Now, another fancy command is rollout history. So just to check what is the rollout history of the deployment index. So you can see we did record this, we did record this. So basically this one is bad one. So we want to roll back to 2. So that's where roll back will come into place. So change this demo, okay? I actually didn't create a demo. I created a deployment with name Nginx. So you need to change that to Nginx. So I am rolled back and my pod has gone, the one which was container creating, and I'm back with my 1.15.2. So that's what deployment is. That's how you create deployment. That's how you can also like kubectl logs deploy nginx. Sorry, pod. You have to do the pods logs, but you can do the kubectl get pods, and you can see logs of individual containers. You can see kubectl. Um, we have done edit. We have done get. We have done delete. So delete deploy nginx hyphen again. I can add force kubectl get deploy. I don't have anything. Deploy. Kubectl get replica set. I don't have anything. Kubectl get pods. I have only previous pods which are there. So I hope you understood now the deployment. So there are many things actually. So we slowly keep on building on top of that. Okay, we started with pods, then we built on the multiple containers, init containers, did some complex operations over there. Now we are going to the deployment, and now let's move to the next stages and see what all things now we can do. But I hope you understood the concept of deployment. Let's go back to our notes. What happens when uh, you want to run databases like stateful applications? What happens when let's say you are running a database? So let's say you are running a database and you created a deployment, because you right now know the concept of deployment, and you created a deployment and you have created a database with that deployment. So you have seen that deployment will be creating a random hash. Okay, deployment creates a pod with random hash, and whenever the pod dies, there will be a new hash. The hash will change, and it can be backed up by any service. So there is a service. So there is a service which is sending the read request to any of the replicas. It's a deployment, right? And it is sending the write request to any of the replicas. That's a big problem. If I send a write request to a database to the replica, this one, to this replica, then in the next one, I am sending it to this replica, second one. There will be data inconsistency when we do the read operations. There will be data inconsistency because deployment doesn't create sticky sessions, or it doesn't do it doesn't create the sticky session, and it will always. Now let's say we have given the pod name or the pod IP. Okay, write only to this pod. But again, if a pod dies, it will recreate, again loss, because it doesn't start with the same name. So for these scenarios, there is another object, another Kubernetes object, just like pod deployment. There is something which is called a stateful set. So whenever we want to deploy stateful application means the applications which are persistent, where you need to persist the data, where you need to persist the state, like you are entering your information and you want to persist the database, your name, email, etc. Those are persisted in the databases. So those are deployed, the databases are deployed as stateful set. It is not a very straightforward process. It is not as easy as it sounds. There are many things that you also need to take care with Kubernetes. So you need to take care of the replication. So replication won't be done by Kubernetes, but stateful set also gives you some capabilities that can help you in your in running your stateful workloads. So it will help you. It will create a pod first. It will be creating a pod with predictable names. So if I create a stateful set with named web, the pods will be created web 0, web 1. Anytime web 1 dies, it will always be recreated as web 1. So I always know the names. So now if I want to send the data, so I can do the write operation only on one particular service, and service can choose only one particular pod, and read operation I can do from both. And then I can have my manual replication mechanism that I need to write, because Kubernetes won't handle that. And for this type of things, for stateful set, you cannot use just any service. You need to use headless service. We'll cover the headless service in detail, but a headless service is you have a pod or your app, you can have a pod or your app to directly use the DNS names for writing, and then have a replication mechanism in place. So you can use headless service, and your pod or your application can directly use the DNS names for writing into the stateful set pod, so that there are no data inconsistencies, and then you can have the replication mechanism between the other replicas of that. Replicas also are very interesting in this, what you call stateful set, because when you increase, there will be a replica set, new one created with the same, with a sequential order. Like the next replica that will be created will be 2, web 2, and your replication mechanism will copy the data, and this also will be ready to serve the traffic, ready for the read operations. So you can create a highly available kind of cluster using this replication mechanism. I know there are operators actually, like Percona is there. Percona gives you a very good operator that gives you 3 stateful sets bound by 3 volumes, which are dynamically allocated, and then you have those replication mechanisms, the HA kind of cluster, which automatically takes care of the replication, which automatically takes care of the read write operations. I think people are making this easy, though it is not straightforward. Then you have, this is covered. Yeah. And on the deletion side of things, so when you delete the deployment, it can delete in any order, but when you delete a stateful set, it is deleted in the order 2 first, 1 then 0. So it is deleted in the reverse order. So that's what a stateful set is for your stateful applications, databases, and maintains a sticky session with the predictable names. You use headless service and it gives you the DNS. Let's see if we have a demo for that. Yes, we have. Okay, so demo is very interesting, because I will make you install the local path provisioner first. Okay, I have only 6 minutes left, so probably I'll restart my terminal because I don't want to get interrupted. Please check your time session for your killercoda environment. Okay, so let's kubectl, let's check kubectl nodes. Cool. And viss.yaml, oh, not this one. So first is directly you apply. So this is a local path storage. This helps you create your 2 Kubernetes objects, basically volumes, which is called kubectl get pv and kubectl get pvc. So basically, if you do not have a dynamic storage provisioner, so this is a provisioner. Whenever you create a PVC, it's responsible of the provisioner to installed onto the cluster to create a persistent volume for it. Persistent volume is nothing but a disk from your local computer. So like you have a local system which is there, or you have a VM, so it's a disk partition which is there. If you have like that is local. One is remote, which is living outside of the cluster. So this one will be inside the cluster, which is fine because we are doing for testing, but we cannot use this for production. For production, we use the external local path provisioners, which are like the cloud volumes backed up by cloud volumes, or which are backed up by the dynamic provisioners, NFS, cluster FS, and all so on and so forth. So, and it will automatically create a storage class for you. So if you do kubectl get sc, you will get a storage class. Now let's do the ss. Copy your pod. Copy your pod. And here what we are doing is we are creating a stateful set. We are creating a stateful set. We are giving it a, we are specifying a service name. Service name is Nginx. We have to specify the service name because we are creating a service type, cluster type none. And how do we create a headless service? Is just we specify cluster type none. Don't worry, I will cover this in detail in the services section, but it is okay. Spec section involves replicas. I want two replicas, same as deployment. So it is almost a copy of deployment only. I have an image, I have container port, I have volume mount. Now here, this is interesting. Volume claim template. This means I want PVC. So if I define a PVC, this will create a PVC. Now, if you have a provisioner which we just installed, so a provisioner which we just installed will read the persistent volume claim template and automatically create a PV for us, and then PVC, and then bind it together. And then the pod can use that. So a pod inside can mount the persistent volume claim on the path this, and it is storage class, access mode. I have already written everything because we have storage class local path. kubectl apply -f ss kubectl get pods get pv. So you can see right now no pv is there, provisioner must be running, and it started creating the pv. And kubectl get pods, you can see kubectl get pods. Right now the one will be creating web 0, web 1 is pending because its pv is not getting created. Now second pv is created, second pvc is also created, both status are bound, and now our pods will be container creating. Perfect. This is how your stateful set works. So you know the name of everything. You know the name of the pods. You know the how a PVC, first the PV getting created, PVC is getting created. So that's a complete flow. Now what we actually can do is we can exec into one of the pods and do, because it's a volume, right? And we can same we can do here also. Exit web 1, sorry, not web 2. We haven't scaled it yet. Anyways, web 1 and echo. Now if I do localhost, curl, and I'll be able to see hello from Saiyam. If I do curl, what was our name of the service? Nginx default. So I need to pass it in a way. Where did it go? Stateful set. Yeah. So I need to pass it in a way which is yeah. So type web 0 dot nginx dot default dot svc cluster local. There you go. So what I did here, I gave the pod name. So I told you predictable DNS. So I can use this DNS to actually write into the pods, and then I can do my replication mechanism. So this is web 0 pod name. Then you have your service name. Then you have the namespace, and then SVC cluster local. So that's your DNS is getting resolved. So you can also see, I think, /etc/resolve.conf, and you can see over here that it is it already has the default SVC cluster local. So we just need to give web 0. So I think even this should work. Yes, because rest will be automatically resolved. So I hope the stateful set demo was interesting to you and you learned something. Now let's come to the next section, which is the important one. Just stay here because next portion is your favorite, networking. And I have prepared some interesting demos to exactly show you how this will work, and you will actually find it interesting because you will get to know how things work. So what you will get to know what happens when you run the pod, how things are getting. So someone was asking CNI. This is where CNI comes into place. So let's start with networking. So we have covered good stuff. We have covered till stateful state. Now let's start with networking. Just a second. Yeah, let's start with networking. I was thinking to cover. Okay, we can start with networking. No worries. So now again, you have to open your minds, and freshen up because this is something interesting, but it does involve picking your brains. So you need to relax, calm down, and hear what I'm saying. So let's go here. So what happens when you run the pod? So we do kubectl get nodes. Okay, so we have two nodes. We have a pod YAML. Whenever we create a pod, it creates a pod. Very simple. It creates two pods. So this particular container is a multi-container pod. It has two names, two containers. It has one container which is name busybox, and second container which is name nginx. And after the pod is created from here, the CNI will attach. The CNI, which is the container network interface, attaches the IP address and attach it to the network. How it does that? So this is the node. Okay, this is the node. Every node will be having its eth0 address. Every node has a eth0 from where your communication entry point, all your service traffic data will be flowing. And it has a root namespace. So we have studied, there are network namespaces. In the previous session, Chad explained about namespaces. Linux containers is all about containing different namespaces. You all agree to that. Here also the same magic obviously will happen. So there will be a separate network namespace which will get created. So this is the pod namespace. Here you have the busybox container, you have the nginx container, and also you have a pause container. Now you would really wonder, I just created two containers, why there is a pause container? What is actually the pause container? We'll come to that. So eth0, every pod will get its own IP address. So your IP address is this. So you got the IP address, the CNI gave you the IP address. Now when you exec into that particular, sorry for that, I think every 1 hour it is getting disconnect. Anyways, it doesn't take too much time. Cool. So where we were? Yeah, so when you exec into that particular pod and you do IP address, so you will find eth0 at the rate if9. You'll find this. I mean, obviously it will be different, but for now, this screenshot, as per this screenshot, you have this. So this is the interface that is attached to the pod. And it is attached to the root networks using the veth pairs. So that is something which is called virtual Ethernet pairs. And you can also see the root in that. So you can see, it is getting routed with the gateway and all that stuff. So it is getting over here. Now, let's move on. You know what? Let's do it side by side so that we understand well. Let's go to the workshop, go up till the networking section. So this is the pod. Create this pod, okay? So VIPO and paste it and kubectl apply -fpo. We have created the pod, kubectl get pods. Okay, this is getting created right now. Shared namespaces. Okay. Now, in order to list the namespaces, the command is IP at ns list. We can see we have list, but we also have another node like SSH into the node one. In order to SSH, just type, go to another tab, click on plus, go to another tab and type SSH node one. And here also you type SSH node 01, I think. 01. Yeah. And type IP net ns list. Here you'll be having more list because there are more containers over here. So let's go back. So there are the veth pairs created depending on the CNI. It may be different, but usually it is veth and the eth. But depending on the CNI that we install, that can be different. I'll show you how it is different actually. So first, let's talk about our pause container. So pause container is actually a sleep container. So it's a container that is a sleep container and it holds the network namespace. So the only purpose of pause container is to hold the network namespace. So your CRI container D creates the network namespace and pause container holds the network namespace. That is the purpose of that. How to see that? To see the network namespace held by the pause container. So let's do lsns and grep nginx. So you can see if I do a grep of nginx, I see different namespaces. Like there are two pods of nginx that I can see, and it has a mount and a PID, but the list of namespaces, lsns is list of namespaces. The list of namespaces doesn't give me a list of net namespace. Why is that? Because network namespace, I think, is doesn't not in the higher priority or something like that. But in order to see that, what we need to do is ls ns -n -p and take the process ID from here. First one. Now it gives you all like C group, user, net, UTS namespace, IPC namespace, MNT PID. So you can see the net, UTC, IPC are held by the pause container. So that's how you can see that pause container holds the network namespace, which is there. Let's clear the screen. Let's go back here. So now you know the meaning of pause container. You know every pod gets IP. Now let's run this command ls-lt where run netns, because usually the namespaces will be here. Why I'm running this command is just to see which was the most recent namespace created, so that I know what was the namespace created by shared network, shared pod that we just created. So slash var run netns. So you can see today, 18th of July, latest time, this one, 53. This is the namespace that was created. Okay. Now I can actually show you a lot of good things. So what we'll do is IP netns exec into this namespace and do a IP link. Okay. kubectl get pods. Just see. Okay. Now the interesting things will be happen. kubectl. What happened? Oh, sorry. kubectl get pods won't run on the node. So kubectl get pods, it only runs on the control plane. Shared namespace. Now let's go inside shared namespace. kubectl exec -it and -- bash. Bash. Okay. If bash is not there in sh, cool. And here we will do IP link. Now it says eth0 if12 eth0 if12. Same namespace. So we now know that this namespace is created with respect to this pod. Now, one more thing that I wanted to show was, yeah. Now let's go back. So we now know this is the namespace. Now take this 12. This number here is important. This F12. Now do IP. Now I'm doing on the node. Okay. Remember, I'm doing this on the node. IP link depth and 12. Sorry, not this one. Yeah, you can see this calico. So I told you there are veth pairs, ether eth from the pod to veth of the node network namespace. But depending on the CNIs, it does it differently because they have like different set of protocols, bird, different networking bridge, and all that stuff. So here the pairing is happening on the Calico side. So you can see it already created. So in order to maintain the communication, so how it will communicate with the root namespace is using this. So this is linked to the netns. So you can see the link network. This is linked to the network namespace. Every other pod that gets created, this type of network IP link, this type of IP link will be created for all the pods that you create. There will be a IP link. There will be separate network namespaces. Everybody will be having the pause containers to hold that network namespace. That is how it is working internally. So I hope you got some gist of how networking is working between inside the containers. Just to recap, so you have a node, you have root namespace, you have the pod gets created, and the container D creates the network namespace, and pause container holds that network namespace. The CNI attaches this. So CNI is responsible for attaching the eth0 to veth, and then the kubeproxy is responsible for creating the IP table rules. Okay, you are seeing the links, right? And now it can be veth eth0, and or it can be the other way around depending on the CNI. If time permits, I'll show you the veth kind of pair as well. I have the example for it. Now let's move on to inter-node pod communication. How inside a node it communicates to the pod. Let's zoom in a bit. So you have, this is a node. Again, this is pod A and this is pod B. So suppose pod A has to send the traffic to pod B. How it will do? The traffic first reaches to ETH0. Then the traffic packet goes to ETH0. Then VETH acts as a tunnel and traffic goes to the root namespace. Then bridge resolves the destination address using the ARP tables. So there are the ARP resolution tables that have the addresses. So this will be having the IP of this, and how VETH will know where to transfer, like the bridge will know where to transfer. It will read from the ARP tables, and then VETH will be sending the traffic to pod B. So that's how the traffic travels. So ETH to VETH pair, in this case, it was like Calico stuff, which was IP link, which is there. Then bridge, then VETH 2, and then from here it goes to the pod B. That's how the flow works. Let's see how node to node communication works. So now you have node A and node B. Okay, node A and node B. Now a traffic has to be sent from this pod to a different pod. Now cannot use ARP as destination is not the same node. So ARP can be used if destination is the same node. Now destination is not the same node. So what will happen? To check if the destination is not on the same node, it uses bitwise operation or adding operation. So it uses the bitwise operation. After that, it forwards the request to the default gateway. You have seen here, right, somewhere, default gateway. So this is the gateway. It will be sending the traffic to the default gateway. Come down. After the default gateway, the default interface of the other node. So there is a gateway here. So there is a gateway here. After this, it goes to a default gateway, and then it goes to the other nodes ETH0, and then obviously after that it again uses its own ARP tables and send the traffic to whatever pod it wants to send. Services uses mostly IP tables and net filter, and the core DNS for the service discovery and stuff. So it will be this, but let's understand what services means and how do we communicate and all that stuff. So this was about networking, pod to pod communication, node to node communication, inter-pod communication, how you can see the POS container. POS container is very important. I hope you got some good gist of the POS container. And to be honest, this video is not a networking video, so I would just keep the knowledge to the Kubernetes ecosystem and not going into the core networking concepts, because if you go into deep core networking concepts, then there are tons of networking concepts which it's hard. So services in Kubernetes, very important concept. Let's just see if we have completed everything from the workshop. So I have written here, okay, all the steps. Check the network namespace. This gives list of all namespaces. Exec into the namespace to see like IP net ns. Exec the namespace, then IP link. kubectl exec shared namespace to IP address. Make sure IP is small. Now you will see ETH9. After @ there will be a number. You can search its corresponding link using IP link grep and 9. So in our case, it was 12. You'll be able to see same network namespace after link. These are the VETH pairs, or based on the CNI different. How to check POS containers? You can actually see LSNS grep nginx, and then you can see the LSNS-p, the PID from above. You'll be able to see the POS container, which is holding the network namespace. So I hope I have clearly explained how to perform this lab as well. Cool. Now services. Easy stuff. Right? Looks easy. Lot of connections over here. Let's try to simplify. So services in Kubernetes are a way to send traffic. So in the end, what you want your end user to access your application. So our end goal is a user should be able to access our application. So when a user wants to access the application, they will be creating a service. So Kubernetes has an object called services, and it helps to navigate the traffic, route the traffic from external or internal to other pods. So you can see why services. Pods keep and coming going. So pod will come and go. So pod IP will keep on changing. So there is no way we can define a particular IP for our application to use. or for our DNS name, whatever it is, we need a virtual IP, which is constant. So service IP remains constant, and it load balance when you have multiple replicas. So it automatically takes care if your node and your two replicas are here and one replica is here, and the request comes to this node, it is intelligent enough to forward the request to this and not to this. So load balancing and all that stuff is also there for the services. Now there are 4 types of services. One is cluster IP. Cluster IP service is the default service. So if you do not specify anything, automatically a service which is created is called cluster IP. So, and in this API version is v1, kind is service, metadata will have the labels and the name, spec section will have the ports and what all ports you need to open, what is the protocol TCP UDP, and what is the target port of the container. Target port is important because if you have multiple containers, how will you define to which port it should go, to this or this? So you will give the target port of the container. So if I want to go 80, so this is the target port that it should go to. And now I need so let's do this. We ran a particular pod kubectl run nginx -f image nginx, our favorite one, and then we exposed this pod kubectl expose pod nginx port 80, and then we get the svc, we get the nginx svc. So you can see the nginx svc, and it got a cluster IP. So by default it created a cluster IP service. And when you see the pods for that, you can see kubectl get pods -o wide. There are 2 IPs for that, and those 2 IPs will be listed in the endpoints. So there is another property which is called kubectl get endpoints. You will never deal with it. It's the responsibility of the endpoint controller. Whenever there is a new pod or this pod goes down, another pod comes up, its IP will be changed over here automatically, and the service will be sending the traffic to this particular endpoint, which is always keeps on getting updated with the latest and the greatest one. So, and this should remain same. Okay, so you have your labels app run nginx. So this is how it selects. So you have 2 pods with the label run nginx. It will automatically be selected. So that's where selector comes in. So select the pods based on the label run nginx and send traffic to those. That's how it selects that. Multi-ports, when you have multiple ports to handle via service, then you need to name them. So right now you have single port. Even if you do not name it, it's fine. But when you have multiple ports, you will need to name those ports as well. You need to have add additional field called name. Next type of service is called node port. Now cluster IP service doesn't actually gives the access of from the outside world. So in order to access cluster IP, you would need something called ingress. For that, you would need something called ingress controller. So for cluster IP, you cannot do directly. You would need ingress, and then only from ingress controller, you will be able to map to cluster IP. But we want traffic from outside world. So ideally, the best path is ingress controller, then create ingress, which maps to this particular service. That is the ideal behavior. But you can create a load balancer service. It is specific to cloud. It gives you the external IP. So here you are seeing, right, external IP is none. It will give you the external IP. Or you can do node port, which is not recommended way. So you can in the type of the service, you can mention --type is equal to node port. You can mention this. It will be accessible on node IP node port. Node IP node port. So that's this. And then last one is the headless one. Obviously, when I'll do the demo, we'll make it more clear. Headless one, I told you, is used for stateful set. Here you have to define cluster IP as none. Headless is used for stateful set. You can communicate with the pod directly using the DNS. I showed you how to do that. To avoid any request being load balanced behind a single IP. This was the curl command that we actually ran. Curl web nginx web 0 service name namespace svc cluster local. Let's try to now do the demo and understand services in a more clear manner. And okay, are you ready? Let's do it. So let's run kubectl engine. First, let's remove all the pods. So kubectl, delete pods. Okay, delete stateful set hyphen all hyphen force. So this is I'm running. Make sure you're running on the control plane. Okay. Stateful set and kubectl delete pods hyphen all. Come on, go delete. I'll make it force. Kubectl get pods. No pods in the default namespace. So we have to be in a clean state. So let's start. Let's go do it quickly. This we already know. Kubectl run, and we'll label the pod. So kubectl run. Two pods are created, one by the name of nginx, another by the name of nginx2, and now we are labeling the second pod manually to have a label run nginx. That's why we are giving a override, because that key is already present, that label key is already present. That's why you want to override. I just want to do it for fun, to be honest, because I want the service to get these both pods. Then expose, let's expose this, and let's dry run, get a dry run of that first. Oh no. Okay, oh, it's fine. Let's get a dry run of that. So this is the kind service. You can see the spec, and selector is run nginx, and kubectl get pods hyphen show labels labels. We can see both have run nginx. Okay, let's create this now. Expose. So in order to just imperative way is kubectl expose pod nginx on port 80. Service exists. Okay, kubectl get svc. 30 minutes, is it? Kubectl delete svc nginx, and we'll create our own service over here. Kubectl get ep endpoints, and you can see kubectl get pods hyphen wide. So you can see 192.168.1.8 and 192.168.0.8. Both the pods are there in the endpoints. So our service is there, and if I do kubectl get svc, if I do a curl on this particular service, I'm able to access that. Welcome to nginx, you can see over here. But I cannot access this still from outside world. So let's change this service to node port. So kubectl edit svc and change the cluster IP. Sorry, just give the name also nginx. Change the cluster IP to come down, change the cluster, change the service type to node port. Kubectl get svc, and now you can see it has a node port. Now in killercoda, you can go here, traffic ports, give a port, access it. Welcome to nginx from the outside world. You have done it. And yeah, that's pretty much it about services, to be honest. So let's move next. at least let me cover what all I have prepared. So it is the authentication, authorization, and admission. So I told you, whenever a request comes in, it goes to the authentication phase. Authentication phase is actually the credential check. So there are two types of users. One is the regular user. Regular user is managed by the external user management system. It is not managed by Kubernetes. Kubernetes just manages the service accounts. So it is managed by Kubernetes. Whenever you create a service account, it will create a secret, which will be having a token that can be used for authentication with the Kube API server. Listen again. Whenever you create a service account, it will create a secret token can be used to for authentication. I think from 1.24 you have to create the token from 1.24 version. Now before the authentication phase moves to the authorization phase, it added a few info like the user info, username, UID, groups, fields. All these things are added in the authentication phase, and these are the set of authentication plugins that you can just read more about. I've just mentioned it over here. In authorization phase, checks if a user is allowed to perform the requested operation, and admission is a policy check via the admission controllers like the image policy webhook. Very simple example that I always give. I want to only have a particular registry from the images where the images should be there. If it is from any other registry, then it says don't admit this request and reject it. So we can do always allow, always deny in the admission controller check. Cool. Let's do the demo for this. Let's do the, so I'll not do the simple demo. Actually, what you can do is, I can tell you about the a bit about RBAC as well. I haven't written anything. Okay, RBAC is role based access control. So basically what happens is you have a node, sorry, you have a service account. Okay, you create a service account, and you have something which is called cluster role, cluster role binding. Then you have role, and then you have node, role binding. These are cluster wide resources. These are namespaced resources. So when you create cluster role, you can bind that with role. When you create a role, you can only bind that with role binding. So in the role, so when you create a role, you define the verbs like list, get, and the objects on pods, deployment, and then you create that. And in the role binding, you give the service account. So you give this service account and the role, so that you are binding these together, and this is defined in the role binding. So that's a basic about cluster role and the RBAC. But let's try to authenticate first. That's a very interesting demo that I think you will like it. Not this one. Authentication. Cool. So first is let's do a kubectl config view. Do a kubectl config view, and kubectl config view will give your cluster IP, cluster address, and all that stuff. Export it. Export the cluster name. Your cluster name is Kubernetes. Sorry, your cluster name is actually Kubernetes. And then you export the API server. API server you can directly export using the I'm directly getting from config view. So this is another command, kubectl config view -o/json path cluster server. I'm getting that. Why it is getting clicked so many times? Anyways, clear the screen. Now let's do a curl. So we got the curl command output. Now API server version. This is open endpoint. But but what about deployments? If I want to view the deployments, it says unauthorized, forbidden user, because it is saying that the user system anonymous cannot get the deployments. So reason is forbidden. We can get this if we pass the client cert. So we need to get the client cert and the key. So let's use this. Yeah, so key, first we have to create the key and the client. So how to create the key and the client is kubectl key and the client. I have not mentioned, but you have to get the key and the client from the kube config. I have mentioned that. So go to dot kube and config. So you have the client. So you have to do echo and base 64-d. So this is the certificate. Okay, this certificate. So we make file client and we add this. Now let's do the key. I think this is the key. Do same echo. Show you again. Okay, echo double quotes, paste that, pipe base 64-d. Basically this is base 64 encoded. We are doing base 64 decode. We are decoding it. This is the private key, vi key, save, and now let's run the command again, which was this, and we are able to get the list of all deployments. Fancy. So we can use the so this is the type of, first was the normal endpoint using the client cert, ca cert. Second type of authentication we have done with the user client, user certificate and key, user certificate and key. Now third type is we will be using service account token. This is what I was telling. Third type will be using a service account token. So in Kubernetes 1.24 you have to create a service account token. So let's create that token and let's go use that bearer token, and you can see you can again authenticate. And from inside the pod, like if you go inside the pod, you can use this token to authenticate to do the same kind of request. Also you can do kubectl proxy. I can show you that, like kubectl proxy you can do, and you can again curl localhost. So if you do kubectl proxy, you should be able to localhost 8080 and whatever stuff is there. Cool. So you have done the authorization, like kubectl get first. You can actually create kubectl create service account Saiyam, kubectl get service account, kubectl create cluster role, and you can do where is that? No, not this one. Here, kubectl create hyphen m create role. Yeah, so you have to give, I was seeing example, a quick example, if I can give you. So a pod reader. So create a cluster role, name pod reader, that allows you to perform only get operations and watch operation and list operation on pods. So let's create this particular role. And let's create a cluster role finding and take help from it. So let's kubectl create a cluster role binding. Wait, I'll not create it. Let's create a cluster role binding with the different name, with the name demo, and with a cluster role of whatever we defined earlier. That was pod reader. Pod reader. But we need to define the service account as well. Go slow, and yeah, hyphen service account. I think we can give service account. Yeah, so we have to give like this. Okay, cool. Come on, copy paste, and let's go above, and we'll do this. Reader hyphen service account name. Service account I think is in the default namespace, and service account name was Saiyam, I believe so. kubectl get, and I think we can use kubectl auth can I hyphen help with the service account name. Can we do that? Can I create pods? kubectl auth can I using service account. Yeah, this is the one, and this is the yes, kubectl auth can I list. Perfect. And yes, I'm able to do this is system service account. So let me use, yeah, that is fine. Yes. List, and if we do create, you see, so I can get, so you can see all the verbs which are there. So you can read actually more about the auth can I command in the default namespace. So this was the RBAC stuff which is there. Yeah, RBAC is actually a bit, it's not Kubernetes 101 topic. So that's why I just covered the overview of that. If you want to go like more deep dive, I can create a separate video, but it's out of scope for Kubernetes 101 to be honest, because RBAC has a lot of user group verbs, which you can actually view. So you can see the resources, you can see the stuff, you can see the service account permissions as well. So there are commands for it. So kubectl, so that's how you create the role binding. You give the API resources. The docs are good actually for this. I didn't want to cover RBAC, to be honest. I just covered because someone asked to give a gist of that. And you can see I don't have that in my notes either. Okay, so the next topic is also very important, because when you create your Node.js application, or when you create your Python application, you provide that property files, you need environment variables, you need all those data which can be replaced, you need some usernames, you need passwords. So how you can actually use that in Kubernetes terms? So you can use something which are other Kubernetes objects called config maps and secrets. So they are application properties. Config maps are the application properties needed by the application. Very simple. You create the application, so you need that. And the secrets needed by the applications are secrets are needed by the application. There will be sensitive data like the passwords, etc. So you can create those using config maps and secrets. So example, so this is a API version v1 and data. So kind, I mean, you can shuffle it anyways, but kind is config map and data is actually key value pair. So data is key value pair, and metadata will have the name test. Now inside pod, this is where it becomes interesting. Inside pod, how you'll use that? So inside pod, you'll be having spec section, you'll be having containers, the same containers, image, command, and then you have env. In the env, you give the name. What will be the environment variable inside the name, inside the container? What will be the name of the environment variable inside the container? And what will be its value? Its value is coming from, so very clear, right? Its value is coming from config map key reference. This is the name of the config map and this is the key. So I have made the label. So this is the name of the config map and this is the key of the config map. So your look inside the container, has the value demo. That's how you can use environment variables config. Second important point is config map as volume mount. So you can actually volume mount the complete config map. Again, example, API version, metadata, kind config map, data. So here data will be file A, and I want two files, hello, Saiyam, learn, Kubernetes. File B is test2. Now I use that inside a pod. Inside a pod, I create a volume, and volume is of type config map, and I give the name of the config map. Inside the container, I use volume mount. I give the name of the volume demo and I give the mount path. Now, if I go kubectl exec into the pod, I do /home and cd config and do ls, I'll be having those two files, file A, file B, and those content of file A, whatever are here, content of file B will be test2. That is how it is. And we can see that in action. Let's do the last lab. Kubernetes config maps and secrets. So let's create a config map. You can create config map from literal, from string, from file. So there are multiple ways where you can create. Clear the screen, create config map, create the pod. You know what? Let me tell you another fun fact. At EOF kubectl apply -f enter. Let me do, got the wrong arrows. So if you do this, press enter, paste the YAML file, press enter, do EOF, it's created. So cat EOF pipe kubectl apply -f just a tip if you want to do it for fun. So the pod is created, kubectl get pods, and the busy box. So kubectl, what do we have to do with this? Example, okay, pod is created. What is it? Okay, I have to do the env, right? Kubectl logs and busy box. You can see there should be look demo because we created live demo and the env name is look. the value is coming from the config map test, and the key is live. So value should be demo, which is correct. So it is look, and the value is demo. Perfect. Demo 1 is complete. Let's move to example 2. This time we are creating a file, a config map from declarative way. So creating a config map in a declarative way. kubectl apply uf. So demo wall 1 is created. It is just the same that I showed you. Let's create the another container. Line number 2. vi pv. What is wrong with this? API version kubectl apply -f pv. Oh, so when you are trying demo 2, just make sure to add a space here. Okay, after API version colon, add a space over here. Now let's exec into the pod and see the files which were there. So we have to go to cd config cd/config, sorry, which file it is. Mount path is home config. Okay, cd/home/config ls file a. Okay, hello Saiyam, learn Kubernetes, keep it up, you're learning awesome Kubernetes. Cat file b and test2. Cool. Let's try the last one with secrets. So let's create a secret. In order to create secret, it's very simple. kubectl create secret. We want to create generic secrets. There are different types of secrets like password, docker password, and all that stuff that you can use. And this is from literal live demo. So I have created that. kubectl is not found. Oh, I'm inside the container. Please make sure you're outside the container. Secret is created. kubectl get secret. And kubectl get secret -o YAML. You can see the data. It is base 64 encoded. I can actually check the value same way. Echo double quotes base 64-d, and you can see the value is demo, which we actually gave here. And then let's create a pod with the secret. This is a busy box pod. kubectl delete pods -all. Now it is created. Yep, so the secret will be there inside the pod. That's it. Print env, you can print the logs. kubectl reports and kubectl logs busy box, and here it is, mounted as secret. Cool. So we have completed all the parts of the workshop for Kubernetes 101, and let's go back and check actually if we have covered everything. So we have covered deployment, stateful set, networking, Actually, instead of this, we have covered the authentication, authorization, and admission and date, and the very basics of RBAC. So RBAC, to be honest, it's like service account creation. Then you create cluster role or role, and then you create cluster role binding and role binding that I created. So cluster role defines actually kubectl get. Let me see if this had the cluster role one. I want to show you one thing. Yeah, I can explain you better, to be honest. Hyphen dry hyphen run hyphen o YAML, because when you see the YAML for this, it will be more clear. So API version for this is RBAC authorization k8s io/v1. Kind is cluster role. Now you define rules over here. So in rules, what all API groups it is valid? It is valid for all API groups. In that resources, it is applied on. Oh no. So when you go here, yeah. So role, it in the rules you define the core API group, and in the resources on which resource this particular role will be there, and the verbs are the actions. Like you can get pods, you can watch pods, you can delete, create. So all the verbs are there. Okay, and then the role binding and the cluster role binding. So role binding is namespace based, and cluster role binding is cluster scoped based. So in role binding, you define the name, subjects. In subjects, you define user or the whatever is that, what you call service account. And in after that, you give the role reference. So in role binding, you are binding the user with the role. You are binding the user with the role, and you can see the main role that we need to understand is the service account one. I think there should be an example for that. To be honest, they have given like all sorts of role, all sorts of permission and subjects la. Yeah, so here it is system service account. So now it will be subjects will be kind service account, and this will be the name. So that's how you define the role and the role binding. I hope now at least it is more clear, the role and role binding. And then we have covered the config maps and secrets. Setup. Okay, I can do that in 5 minutes. Last thing, okay? After that, nothing. So for local setup, for local Kubernetes, you can use Docker desktop. Okay, go here, download it, get that, or you can use Rancher desktop. So I already have that installed. Let me share my screen, to be honest, then only you'll be able to understand that. Share screen, share screen, window, Rancher desktop. So you can see this is my Rancher desktop, and it is starting the container. So it has the application. I have a complete video actually on Kubernetes. So it will be starting a local Kubernetes cluster on your particular node which is there. Now let's go back quickly. Okay, so where are we? Yeah, for local. And then you have minikube. Now remember, minikube is required for your next workshop. So your task is to install minikube on your local system. Minikube is required for your next workshop. So you can choose the operating system, you can choose your architecture, you can choose beta, and you can directly do the install. It directly gives you the command, and then you can do minikube start. You can do the kubectl get a and all that stuff. So you can do a mini kubectl get a, and it will be easy for you. So minikube is also for local development. Now in your somewhat production, not complete production, like one node, one master and 3 control plane nodes, you have something which you can use, which is this. Come on. Okay, let's go here. Yeah, so go to Kubernetes areas and playgrounds and start an Ubuntu playground. Okay, start an Ubuntu playground and just run this particular command, which was here, curl. I don't know if it comes in the chat, but I have pasted. So open the Ubuntu playground and run this particular command. I'll tell you step by step. In the meanwhile, while it's running, I'll tell you step by step what it does. So it's very simple. I mean, pretty simple. So first we are adding the GPG key just to have the Kubernetes stuff. Then we are installing the components vim, get, wget, and kubelet 124, kubeadm, kubectl. So all these things we have installed now. Next step is called the memory swap off. So we need to turn off the swap memory. Then is the overlay, net filter, setting the IPv4 forward, systemctl c, and what we can do, we can actually refer the Kubesimplify Kubernetes 1.23. Kubernetes. Yeah, set up Kubernetes with container D. So this blog is by Saloni, and we have written like step 1, run on all machines. So you have to run kubeadm install kubectl. This is the first step that was done. Disable swap. Swap should be disabled in order to work for kubectl to work, kubelet to work properly. There is a kep to make this work, which is in alpha and which will mark that beta in 1.24. So you don't need that in 1.24 onwards, to be honest. Then load the BR filter module and the net filter and let the IP table see the bridge traffic. So this is for this particular purpose. Then is the setting up of container D. So this is the complete setup of container D. So you get a container d.conf. This is already done. Then you do the net IPv4 and all that stuff. Apply, set up the required sysctl parameters. Apply the sysctl parameters without reboot. Install and configure container D. So this is the curl of that, installing of that, apt install container D, and then you restart and enable container D. From 1.22 onwards, if you do not set the C group driver under the kubelet configuration, kubelet will default to system D. So you don't need to do anything here. Then you do the pull of images. So kubeadm config images. So kubeadm, now we are interacting with kubeadm. Kubernetes cluster will be set up using a tool called kubeadm. So kubeadm images pull, and we give the CRI socket, our container D runtime path. So CRI socket container D, and we give Kubernetes version 1.24 we have given over there. Now is the Kubernetes init. So this is the phase where actually you are starting your cluster. You are bootstrapping your cluster. So this is called bootstrapping your cluster. The pod network CID are dependent on the CNI, and yes, I am also using Flannel. Control plane endpoint will be the public IP of the instance. It can be private as well, but if you want to access it from outside using the kube config, it should be public. So you give the pod network IP CIDR, Kubernetes version, control plane endpoint, ignore pre-flight error memory, because we are running on Katacoda. It requires minimum 4 gigs of memory. If we don't specify ignore pre-flight errors, then it will fail over there. And then the CRI socket. and then it will install. So that's the complete installation. Let's go back. It is installed by now. So if you do kubectl get nodes, so you'll be having one node Kubernetes cluster that you have just spun on Ubuntu, and you can do your first command kubectl run nginx hyphen hyphen image equal to nginx. Congratulations, you have done everything. Whew. So I'll stop sharing the screen now. So great to see many people still sticking over here. It's almost 4 hours, and I think we have covered many stuffs in Kubernetes. That was my aim, actually 3 hours I wanted to cover, but we have done it in 4 hours. Yes, it's super nice that we have covered almost, actually more than Kubernetes 101, because we have covered many things in depth. We have done many examples. The video will be there for you after that, so that you try again all the concepts. The workshop link is there, so that you keep trying, keep practicing again. Any doubts you have, join the workshop channel on Discord, ask us anything, and Kubesimplify ambassadors would be happy to help you out. Make sure to check out the rest of the workshops. Every week there is one, and every week it'll be super awesome. Next one is on GitOps on Kubernetes, so make sure you have done practice Kubernetes very well, so that next workshop you can understand the GitOps, its principle, using Argo CD, do the CI/CD, GitOps principles, and all that stuff. And you will also be able to get the certification for that free of cost, and you can put that on your LinkedIn, on your badges, share with everyone. So next workshop will be super awesome. After that, you'll be having the workshop of Kubernetes troubleshooting. Again, you have to set up Minikube. I'm telling you again and again, the prerequisite for that workshop is setting up Minikube. So make sure you have Minikube ready to launch the clusters when that workshop will be there. And stay tuned. Awesome things are coming up from Kubesimplify ambassadors. A video series is coming up by Kubesimplify ambassadors. Thank you so much for tuning in for today's video. Share your reviews on Twitter. Make sure you to tag me, so that I feel energized and I can do more. This I have never taught from such basic level, so I hope it was Kubernetes from scratch for you all. And thank you so much. And these notes are very critical. So I will share them with you. I'll put that in the same repository as a PDF, so that you can download. And do not worry about the notes. It will be there in the repository in coming days. And thank you so much for watching. Keep replaying the video, keep sharing the video with your network, so that everybody learns Kubernetes in easy way. Thank you so much for watching, and join Kubesimplify, follow Kubesimplify on Twitter, follow me on Twitter. And thank you so much for watching. I loved all the enthusiasm over here. And thank you for staying till the end. That's very important. So you people are the best who stayed till the end. Not means that the others are not, but they might have some work. It doesn't matter. But thank you so much for watching the video and being in the live stream. I hope you learned a lot today, and it accelerated your DevOps learning curve. Thank you so much. See you in the next one.